Well, you missed the music, and so did I. Hey, hello and welcome to this July 29th, 30th edition of the SkyTour LiveStream, coming to you live from the wonderful John Zach Memorial Observatory in northwestern Connecticut. The skies are unexpectedly clear tonight. That's why the last-minute notice about the stream tonight. But tonight we're going to explore the beauty and mystery of the universe as usual, and we're going to look at galaxies and clusters and nebulae and double stars, planetary nebulae, globular clusters, and so on and so forth. Now, we call that the astronomical potpourri, and that's what we're going to do tonight. All right? Now, we're going to see it all because that's what it's all about tonight. So, as you know, we'll take questions from the chat room, so feel free to participate. If you want to see a specific object, let us know. You can tell Amanda, she's moderating for us. And, hey, it's all live and it's all uncut, and the system will be fully up in just a few minutes. I just have to let it acclimate a little longer. But we'll be ready to go here in just a couple of minutes. So I'll begin playing some nice music, and we will commence shortly. Thanks, guys. You know, while we're waiting for the acclimation of the telescope, I just wanted to, I've got this star in here right now. This is actually Arcturus, which is Alpha Boötis. And Arcturus is a neat star. Now, you know, you think about our sun and you think about stars like Arcturus. And, you know, they couldn't be more different from each other, because Arcturus is what's called a K1.53, that's Roman numeral 3, and that means it's a giant star, and not just a giant, but a big giant. And as a giant star, it means that it's got a lot more mass than our sun, and it's actually just a little bit cooler than our sun, oddly. But see, the brightness of the stars, it doesn't matter, you know, how much mass a star has. If a star actually has a certain brightness, it means that it has a certain luminosity. That luminosity is related to the star's mass. It's related to the temperature of the star. And if the mass goes up, the temperature goes down, because the star increases in size and its surface is lower temperature. And this is Arcturus. It only has a 4,000 degree Kelvin surface. And if you remember, Kelvin is Celsius minus 273. Okay, so minus 273 degrees Celsius is absolute zero. And we did that because we wanted to have a temperature scale that could start from zero and just go up, because it's a pain in the butt to have things that go up and down and are negative, and, you know, minus temperatures just weren't cutting it, especially if you're putting temperatures into an equation. Makes it a lot easier for us. So, that said, we're just waiting here for the telescope to acclimate. I can still see Arcturus is dancing around a little bit. And I believe Amanda is here. I can hear her typing in the background.
Hi, I'm here. Hey,
I
all.
I knew it. There you are.
We actually did have a question already coming in from Cypher 2.
Awesome. What do you want to know?
They want to know, is it possible to see the region that surrounds the Bootes void?
Oh, well, which region are we talking about?
I don't know. We'll follow up. Cypher?
Follow up. Yeah, Cypher, tell me what you mean by the Bootes void. Remember, I may be an astronomer, but I don't know everything. And when you tell me about the Bootes void, that sounds like an interesting place that I want to go. But a void usually is an absence of something. And an absence of something usually doesn't look very good in a smaller telescope as this. But you never know. We might have something here we can see. And I'll be happy to do it. I'd like to. Alright, I'm going to go to full screen mode on my... There we are. On my stream here, I'm going to full screen. I've redone the observatory a little bit. I actually got a new lit keyboard. It's in a beautiful red light. And I have the red light in the observatory, which I've always had, which you can see in the inset camera. I pass my hand in front of it. You see me blocking it out down there in the lower left. And I actually put a new computer in here with brand new Wi-Fi, so we shouldn't have any buffering issues. I also told my son to stay the heck off of the Wi-Fi tonight because he loves to stream and take up bandwidth, but that's okay.
Dee doesn't believe that you don't know anything, everything.
Well, thank you, Dee.
I agree.
That you humble me, but you know what? The truth is, I still learn every day. I still learn things. You know, of course, I am looking up things that I've not known before. Like when we'll take a look at the moon later before it sets, and I'm going to tell you some interesting things about the dark side of the moon. That is the far side, the back side that we don't see, and the near side. There's some interesting facts that I have been diving into about why the back side has so many craters and the front side doesn't. Very interesting stuff, and we'll talk about that later. And if I start to forget, remind me. And in about 55 minutes, Amanda's going to come in with a new feature that we do, and it's called the This Night in Astronomical History. And she's going to give you some interesting facts that she has dug up on the evening, this particular night, July 29, 30th. Now, why do we say 29-30 for a date? That's something I want to mention to you because it can be confusing to people who say, well, wait, it's the 29th for crying out loud. I mean, why do you say 29-30? When I was getting my degree in astronomy, usually my shift started at 11 o'clock at night and went until about 3 or 4 in the morning. So I started on the 29th, say, and I finished on the 30th. So to let them know which exact moment I was in that observatory, I would say my shift was July 29-30. Now they know it's the night of the 29th and the morning of the 30th. So that's how we did that. And it's kind of crazy, but that's how the streams are going to be labeled in the YouTube system. So you'll see them that way. I can't tell you, I'm not very good at doing that. But Amanda's been very good to remind me to do that. I got to tell you some more about Arcturus here. You know, Arcturus has about 1.5 times the sun's mass. All right, and it has stopped fusing hydrogen, so it's no longer making hydrogen into helium, as we've talked about in the past. That's the fusion reaction. So what's it doing? Okay, it's actually making helium into carbon. All right, and it's using probably using something called the CNO cycle, the carbon, nitrogen, oxygen cycle, and the CNO cycle is what supports these larger stars. It's the kind of thing that makes the larger stars actually have a fusion process that can keep them stable, and that's what this is. So Arcturus is very, very cool that way. Now, as far as the location of Arcturus spatially, and some of you already know this probably. But Arcturus is actually 36.7 light years away. It's it's really not that far away. It's kind of close astronomically, and this is kind of cool. And one of the things that I wanted to tell everybody is that someday, if we ever get to go to Arcturus, then we're going to see, we'll understand, in fact, how much bigger Arcturus is compared to our sun. Now, I said that Arcturus has 1.5 times the mass of our star. However, if you put Arcturus where the sun is, it would absolutely dwarf the sun. And if you went side by side, put the sun side by side, which is 850,000 or 860,000 miles across, the sun is, you could probably put around 20 suns across Arcturus's front. And that would go to the diameter of Arcturus. And remember, a diameter means it's a sphere, and that takes up a huge amount of volume in space. And for those of you that want to know, the volume calculation is 4/3 pi r cubed, which is the radius cubed of a sphere. And pi, remember, is 3.14, or apple. That's a little joke. Sorry, very little. Anyway, telescope is up and running, and it's ready. And I'm going to take us now, because I want to talk about this. I want to talk about the moon a little bit. So let's just go check out the moon. Hey, Amanda, will you do me a favor? Could you let Keith know that I've started?
Okay.
Because I think he wanted to, if he wasn't going to pop in, he was going to mention that we're all up. This is the first night, I think, that Bill New York Skywatcher, P&K Space Imaging, and SkyTour LiveStream are all live. And we can be found on astroimaginglive.com, which is our little consortium's website that we put together. And Amanda's been helping us in the background tremendously on our individual streams, as you know, and doing a fantastic job. I want to thank her publicly for that.
Oh, you're very welcome.
Well,
I'm still stunned every day that you guys let me hang out with you, because I know nothing about this, but
that's okay.
I'm willing to help, so.
Yeah, and that's wonderful.
Okay, I just messaged Keith.
All right.
Give me a second. I will get his link and the Astro Imaging Live link as well.
And I'm moving now to the moon. It's probably going to be blown way out, as it is, you can tell, right now. But that'll change as I alter this a bit. Okay. Yes, sirree.
Sure. And the Astro Imaging Live, when you go there, you can see all three stations. You can see Mark D'Antonio SkyTour LiveStream. You can see P&K Space Imaging, who mainly focus on the moon, some planets. They're going to start doing interviews. They do the occasional solar streams. Check them out. And Bill NY Skywatcher, who does a lot of meteor showers. He's also a producer at KGRA, so he streams a lot of live shows as well. Right. So check them all out. And Astro Imaging Live is where you can check out all three. It's a quick stop to see who's streaming. If you missed anything, pick and choose. It'll bring you right to YouTube. It's brilliant. It's a brilliant site. So check that out, guys. Bookmark it as your favorite.
Yeah, I actually already did, because you know, I forgot the name a couple of times, and I had to keep beating it into my head. Wait, Astro Imaging. No, Astro Imaging Live Stream. No, astroimaginglive.com. So it's like astroimaginglive.com. You know, you gotta make it a musical thing. You'll never forget.
Yeah.
So here on the moon, I wanted to show you something interesting. Now, when we look at the moon, we see that the near side, the side facing us, as you can see, it has craters, of course, but it also has these dark maria, right? These flood basalts, these areas where lava flowed over the surface to create these seas on the moon. Now the moon's a little bit low tonight. It's starting to get low, so it's starting to be a little bit yellow in the sky right now. But I wanted to tell you, when you look at the moon, and you look at the front side of this moon and the back side, you see that the back side has a massive number of craters, far more than the front side. Now the question is, why is that? Now, it goes back to the beginning when the Earth was first formed. Somewhere along the way, early in the Earth's development, we got hit by something, a larger, another planet, possibly Mars-sized, collided with the Earth, and a massive amount of our early planet was sloughed off, blown out into space. And for a time, those pieces kept orbiting and crashing back into the Earth, And some of them began to coalesce into a ring of sorts around the planet. And then over time, more billions of years, okay, the ring coalesced into one object, and that became the moon that we see. Now, people were saying, and I've said before, that the fact that one side of the moon faces us all the time means that the moon is tidally locked to us, meaning that gravity and the forces between the Earth and the moon conspired to make sure that one side of the moon faces us. That's what happens when something is very close to the planet. The moon is, if you see it, it's not really that close to us. However, we do look at the moon and we see that it's close enough so that we will get the moon tidally locked as it is. That said, if we consider that we could then take our imagery of the moon and compare the front side to the back, as I said, and then we look at the cratering differences, we have to come up with an idea as to why. And why is that? Well, we thought, well, the near side is more protected, isn't it? It seems like it might be more protected, so maybe there's less meteors hitting it because they would hit the Earth first. Undoubtedly, there's something to that. But that's not the only reason. Then the idea is, well, maybe it's just that this side of the moon was the side of the moon that actually got hit more. And basically, more lava escaped to the surface and ended up going all over the moon's surface. So maybe this is the more cratered side. And maybe the Earth caused that. And that's a possibility. But it turns out that the moon is equally cratered on front and back. And you say, well, but of course not. I know it's not. I mean, I look at the back side of the moon, and it's got far more craters. It's everywhere you look. Every single inch, every single spot is heavily cratered. Yes, and so is the front side, the thing that we're looking at right now. At least it was, until the other impactors hit the front side and the lava spread. Now, why didn't we see that happen on the backside? Why are there no maria like this, the gray areas like this, on the backside of the moon? Turns out, the moon, believe it or not, is lopsided. It doesn't have the same consistency in its crust on the front side versus the back side. And you say, well, what? How could that be? This has been something that has stumped the planetary scientists for many years. And when we started to look at the processes by which the early moon cooled, we can't take out of the equation that the processes that allowed the early Earth to cool were just as important. And in this case, when the moon was young and still semi-molten, the Earth was also semi-molten at the same time. And the Earth was radiating infrared energy to the moon as well. And the moon was radiating infrared energy out into space to the Earth as well. Now, the moon had already been tidally locked to the Earth by that point. But what happened was, when impactors would strike the moon, they would be thrown up into the air. But because the Earth was still very hot and because the moon was still very hot, the combined heat, basically, the infrared energy from the Earth and the moon may, I say may because this is now a hypothesis, may have held the molten particles from the impacts on the near side of the moon as molten for longer, and they didn't cool. However, there was a process by which they would actually be, because of the moon's gravity, they would move around the moon, and they would tend to settle on the back side of the moon. And if that was the case, as they settled on the back side of the moon, they would cool, as they should, because there's no infrared energy from the Earth. The Earth is big. That's a big radiator aiming at it. And because the radiator, that is the Earth, was not present, when the particles that were molten could reach the other side of the moon, they would start to cool. And when they finally fell to the moon's surface, there they stayed. What's the net result over millions and millions of years? The net result is that the crust on the backside of the moon became thicker. So, when we had more bombardment, and there's an early bombardment era, late bombardment era. In the late bombardment era, when the moon was pelted again, the crust on the near side of the moon was thin. So every time a meteor, a big impactor, hit the moon, it would basically make the moon bleed. It would actually, allow for the upwelling of lava, like we see here. So we saw Maria that appear on the moon. Meanwhile, on the backside, big impactors just made big holes. And the craters were, simple craters, complex craters, which we'll talk about in another session. But the bottom line was that looking at the moon, it had a whole story to tell us that we didn't even know. And we may still be wrong about this, but right now the prevailing theory is that the moon and the backside and the front side are different because the Earth was preventing the material that was in lunar orbit around the moon from cooling and falling to the moon to make the crust thicker. It went to the far side of the moon, the other side, where it then fell unimpeded. Interesting, isn't it? And
that's very interesting.
Yeah, it's a theory, and this has been something that planetary scientists have been wrestling with for decades. About why the Maria on this side of the moon? Why do we have a man in the moon? So, I thought that was just a very cool little concept, and I've just started to skim the surface of this. So if anyone has questions, feel free to ask, because I'm necessarily leaving a lot out so that we can, see stuff. So, that said, let's go back and take a look at the whole moon. There it is.
Well, I had a question on that.
Sure.
What do you think of the theory? Do you think that is the most logical explanation, or have you heard something that you like better, or?
Well, see, the tidal locking, that is the moon's face always facing us, that happened early on. In fact, that happened probably very quickly, as soon as the moon coalesced into a sphere. And why a sphere? And why not an asteroid shape? Well, beyond a certain size and mass, objects in space tend to form spheres. And their own gravity overpowers the structural rigidity of anything trying to stay a piece of rubble. And it ends up being compacted and crunched down by gravity. So that's the way it happened on Earth. That's the way it happened on a lot of planets. And don't forget, we're not talking a bunch of rocks. We're talking molten plasticky type of malleable rock at that point. So blobs that are somewhat molten, all right? Like putty that's very thick putty, okay? It's just that it was probably about 3,000 degrees or so, maybe more. So, but for me, the theory that these refractory materials, that is, materials that could stay, molten for some time, these materials, this theory to me sounds more plausible than anything I've heard before. And whereas I've said that the Earth probably protected this near side of the moon, I don't disagree with that at all. I think that's true. But if you look at the south pole of the moon, as seen from the near side, in fact, just to reinforce that, let me just take you there.
That's why this is the coolest channel.
Oh, you like
rather than talk about it, let's just zoom in.
Yeah, well,
I love it.
That's okay. I mean, Keith's doing that too, So let's go down there and just take a peek at it, okay? So now let's go down. I'm gonna actually drop it down a little. Okay. So now if you look at this pole of the moon, okay, in the lunar southern highlands, you see that there's craters everywhere you look. All right, there's a lot of craters. Now the far side of the moon actually looks similar, but it has even more craters. And so that means that the processes that allowed craters to be lost on this side were not in play for the far side. And that's why even with all the theories thought of so far, this theory where these materials actually went to the far side and settled, making the crust thicker, This seems to be the most logical, best theory I've heard for a long, long time. And I'd be willing. See, if I was, you know, I'm looking forward to getting an additional degree in planetary science. And when I do, I'm going to study the moon intensively, because the mineralogy of the moon is really important to what happened here on the Earth. Keep in mind, one of the big problems with the theory that the moon, the Earth actually, the early Earth was struck by a Mars-sized object. One of the big problems with that is that the moon and the Earth actually have very nearly identical compositions. So if an object hit the Earth and the moon kind of got blown off, shouldn't the moon composition be composed of the impactor that hit the Earth as well? But that's the thing. We don't really see that. We only see a composition of the Earth on the moon. And it's not even kind of close. It's very close. So that's always been a problem, you know, with the birth of the moon scenario. We actually don't really know a whole lot about our own origins. And that's what makes it so exciting. I mean, this makes it so incredibly exciting, you know. And then we talk about, you know, we want to talk about going to the stars. We want to talk about finding our way to the new planets around other stars. And it's like, wow, you know, we don't even know our own history. And we're already thinking about and possibly being capable of building technology to take us to the stars already. On a cloudy night stream, I'm going to take you through some of my lectures that I do, my talks. But it'll be exciting because I'm going to be very interactive with you. I'm not going to just talk at you. You're going to be able to, you know, give me questions and stuff. And this will be inside in my office. So, and we're going to talk about advanced propulsion, how to go interstellar, all that stuff. See, out here, it's not a place to do it because I can't really show you on a screen. In there, I can actually show you. You know, I can actually show things, make drawings, show you the things that I'm doing. And you see it dynamically, and you can make comments and suggest changes, all that. So, there's the theory now about why the moon has Maria on this side, but not on the other side. I think that's a very interesting dilemma that we've managed to, you know, possibly make a dent in. And I'm very excited about that theory. Anyway,
didn't you say something about lava escaping?
Well, yeah, when the moon gets pelted with meteorites, it happened. It was pretty even. It was getting hit from all sides. It wasn't like this side got more or the other side got more. The other side has more craters. But that's the end result of another process that was in play. And that end result is that those craters didn't get wiped out by Maria that overfilled them, like this side. The Maria that overfilled them on this side were due to that fact that the Earth was still in its infancy and still molten and very, very hot and radiating infrared energy to the moon and any particles over the moon. And it actually helped keep the moon molten for a long time because of the infrared energy escaping from the Earth. And that process allowed for the particles, which were kind of going in like a roughshod orbit around the moon, they would cool once they got on the other side of the moon. And over time, many of those particles would tend to accumulate on that side, because if they accumulated on this side of the moon, they would get blown back out again by other impacts and end up getting spaceborne again, into space. And that would happen on the other side, on the far side as well. But because there was no infrared energy that was radiating out and hitting them and literally pushing them along with the energy, because again, in space, energy of any kind impacting you can send you someplace. So molten particles would end up moving in a direction that's not to their liking if there was a source of energy that was aiming at them, and that's what the Earth was doing. So it was forcing all these stuff to the other side, and the stuff settled on the far side of the moon, making the crust thicker. The crust on this side that we're looking at was thinner. So anytime an impact happened, we tended to see more lava. Okay? Like in the upper right there, in that upper right, okay, you can literally see okay, you can literally see right here in this upper right area, this is a very, very nice circular crater, isn't it? That was a big circular impact hole, a crater. However, that got filled in over time, and by the lava that was down there. On the far side of the moon, a crater of this size wouldn't have gotten filled in. It just would have got hit by more and more and more things. And that's just what happened, you know, when you look on the other side. So there it is, a really cool satellite that is the moon with some new theories for formation. And that's a relatively new theory. So if you look it up, in general, when you start looking up why the moon has Maria on this side versus the other side, you're going to find a lot of conflicting data. You're going to find people saying, well, the Earth protected them more. And then you're going to find some new research that's available on the archives. ARX V, I guess, ARX, I can't remember what the name is. But I read all the astronomical journals and stuff like that up there. But anyway, that's cool. So I'm really hyped on that theory. So I guess that's enough of that. And right now,
well, couldn't the lava itself have smoothed out the side that was getting radiation from Earth, and it was too cool to smooth out the backside?
Yeah, of course, and that's right. But the lava that we see here, the dark areas that were the Maria, that were the former, molten areas, the whole moon was molten, but these areas were struck, and then the stuff from inside leached out and came out and oozed out because of the fact that it was a thinner crust. And it would still tend to find its own level in the moon's gravity, so it would tend to be a large plane like we see here, circular plane that's following the curve of the sphere.
Would more eruptions on one side than the other explain why it's lopsided? Because of the crust kind of disintegrating?
No, it was because it was lopsided that we saw more lava on this side than the far side. Now, that's interesting because...
But you don't know what caused it to be lopsided in the first place, though.
No, we do. That's what we're saying. What caused it was this process of the materials ending up on the backside of the moon before they cooled and fell to the surface. Over time, that made that crust on that side thicker. So...
Okay.
So what that means now is something else. That means, and we'll get off the moon in just a minute, but what that means is that, in fact, the far side of the moon is thicker crusted than the near side. So the center of gravity of the moon is not at the center of the moon, is it? It's actually shifted toward the back side. Now that's interesting, because then you would say, well, wait, if the moon is shifted toward the backside, then shouldn't the heavier side be facing us? Because gravity would tend to act on the heavier elements, the more dense area of the moon, and pull it toward us. Isn't that true? And the answer is yes, and it's no. It turns out that they did a study to figure out why that wasn't the case. And as it turns out, and this is more than I even want to go into, but I will, because it's cool. As it turns out, there are several scenarios by which the moon could have ended up going either facing us, with its far side facing us, or as it is now, with the far side away. And it was basically sort of a toss-up. And it had to do with the conditions at the time, the cooling rate, how soon the Earth cooled. It also had to do with the way the moon was being impacted by other things. And it was right. The planetary scientists that I was consulting in this were saying that the moon was right at that cusp of being able to flip either way, where it might put the far side toward us or away from us. And maybe one of the impactors, maybe that created one of these impacts we see here that created some of these Maria, may have been just enough to start it rolling around. And like somebody swinging a weight around their head, the heavier part of the weight goes as far away from you as it can. And maybe that's kind of what we're seeing here. And it had to do with the fact that the moon, got hit by an impactor that was just enough to swing it away from us. Now, there's scientists that will tell you, well, the moon should be facing us, the far side should be facing us. And there are scientists that will say, yeah, but the far side is away from us, and we understand why, and that's how it should be. So, you see, with all we know so little. And I just thought that was kind of cool. Really, really neat. And it's really a beautiful night. While the moon is up, it's I can see the Milky Way, but it's just barely there. We have to wait for the moon to get a little lower in the sky before we can start looking at some fainter things. But for now, if anyone, are there any more questions about the moon at all? Because I'd be happy to answer those before we go to our next object.
Just a few kind of within chat. Just do meteors still hit the moon, and has anyone ever captured it, and things like that?
Let me answer that. Yes and yes.
Okay.
Meteors still do hit the moon, and in fact, people have captured a meteor striking the moon before, and that's something that's really interesting because when we look at the moon, you just think, well, it's just a static thing, nothing's going on with it right now, right? And the answer is no. Actually, the moon actually does have some dynamic things happen, and there was a bright spot that appeared on a camera that someone was running for like a Paul and Keith doing a P&K space imaging, and they saw this bright spot, and just on a whim, the folks went to this area on the moon, and they actually found a new crater. So the observers that actually saw this thing hit the moon weren't lying. They actually saw the impact of a brand new impact crater, a new site. They saw the birth of a new impact site. It was great, So yeah, it still does happen. It's not as much as before, obviously, as you can tell. The moon has stayed the same way pretty much for billions of years now. So. All
well,
right.
I thought maybe the logical question after, how big would something have to be that hit the moon to move it, to change its position?
Well, see the size of that Maria on the upper right there?
Mm-hmm.
Okay, that Maria that you see up there, that perfect circular Maria, that is probably less than what's needed to actually physically move it. But it's not just the size of the impactor, it's the speed of the impactor. A small object like that there, hitting the moon at an exorbitant rate of speed, could move it. A large object moving very, very slowly may not. Now, you still have to deal with something called inertia. That is, basically the moment of inertia, which is actually I got to describe this in a way that is sensible. The resistance to movement that an object has is a moment of inertia. So when you go to push something, okay, as soon as it starts to move, you're overcoming it's a moment of inertia, and you're actually allowing yourself to move it down the road or down the thing, or pushing a car. All right, and once that happens, you may not be able to stop it. So that is to say, if a meteor, a big one, hits the moon, it may continue into the moon for some distance, thousands of feet or whatever, and then, at that point, the heat of impact is being generated all along the way of the impact. It goes molten and literally becomes subsumed by the moon and becomes part of the moon. And this is something that I'm sure has happened. That's why the moon, if we look at certain areas of the moon, we see that. When we see rays, like Tycho has these beautiful rays, Copernicus has these rays that come out. That's called ejecta, stuff that came out from the impact. Well, those rays could be from material that is near the surface or deep inside. And that's why some of the lunar missions went to examine some of those ray materials to figure out what those were. So it's pretty cool. Pretty cool indeed.
If I'm looking at the right area, yep. You're talking about like the dark gray area on the top right corner of the moon, and it's kind of by itself.
That one right there, yep.
because
that's correct.
that's not very big. That's not very big for something that could possibly move the moon. Literally, that's
but
that's stunning. I had no idea something that small could make such an impact. Well, speed, of course, being a factor, but
speed's a factor.
do we have a lot of objects that big floating around?
Well, I mean, that's a big object compared to the moon overall. You know, now the Mare Imbrium basin, which is just coming into view right now. We'll see it a little later in the cycle. The Imbrium basin was a major impact. The Chryseum basin was a major impact. The other thing that happens is when something strikes this side of the moon, say, or the far side of the moon, you say, well, that's where the crater is, right? Yes and no. Yes, you get a big crater where it impacts, where the impactor hits. But that force is transmitted through the moon, just like the force through a croquet ball, you know, that you put your foot on and clack the ball, and the ball attached on the right foot, you know, that's up against the ball, and your right foot goes king, goes flying away. Okay? That same principle applies with the moon and the solid moon. And you actually end up seeing the shock waves get transmitted through the moon. They come out and form ripple patterns on the other side of the moon. That is to say, for big impactors, they cause major damage on the other side from where the impact occurred. Just interesting stuff. So, now we're going to leave the moon behind just for now. Because we're going to go to some things and check out some things that we might have seen before. But we're going to go there because I want to. And I want to take us to various places on our astronomical potpourri. Let us see here. Now you don't see anything yet because I have the settings set for the moon. I don't have them set for this. And we'll see that in a minute.
I guess the telescope automatically configures for different distances depending on what you're looking at. You don't have to put that in manually or anything.
Oh, correct. Now, one thing I'm going to try and do more of with you is this right here. This is, we're actually looking at it in 4K live video. And I can actually, I do have camera settings that I can actually do that with, where it doesn't make me use the camera card and store it. But I like storing it. It's great. And, you know, we'll take sections of this and make this available to you on the SkyTour LiveStream Facebook companion site that Amanda put together. And I think that when we look at objects like this live, and we just see them as they are, sitting out there in the cosmos, just waiting for us to explore them, I just think this is really cool. You know, this is, again, this is Messier 13. It's the Great Hercules Cluster. And there are several 100,000 stars in this cluster. And the cluster itself is, as we said, 23,000 light years away. That's 23,000 light years. That's an absolute massive distance. Massive distance. So, that said, I think that it's important to understand that clusters like this are places that you might be interested in. You might say, well, there's a lot of stars there. Could there be planets around those? You know, are there planets around those stars? And the answer is that in this particular case, when we look at this particular cluster, we realize that this cluster doesn't have any planets that may have, or any stars that may have planets. And why is that? Why is that? And the question is answered when we look at how these stars formed and when they formed. These stars are among the first stars ever formed in our galaxy. They're called Population 2. And Population 1 are more recent stars. But the Population 2 stars are what are called metal-poor stars. They don't have a lot of metals in them. What are metals? We talked about this before. Metals are anything that are not hydrogen and helium. To an astronomer, that makes sense. To those of you that are chemistry folks, you might say, what are you talking about? Dude, that makes no sense to me whatsoever. But that's how we think about these things. We think of this as it's a universe full of hydrogen and helium. And when we look at hydrogen and helium, anything other than hydrogen and helium is something that is created primarily in the hearts of stars. All right? And as such, we call them metals. And that's just the way it is. It's a strange world we live in when we come to this thing. We come to this. So, here we have the Great Cluster in Hercules, Messier 13. And as we look at Messier 13, we also have to consider that at the distance it is, and with the hundreds of thousands of stars, the fact that you may not have a single planet around any of those stars is really quite an incredible thing. Now, the fact is, these globular clusters like this, there's hundreds and hundreds of globular clusters, and we talked about them before as being objects. I'm going to take a picture now, so I'm going to come off of the camera mode and go for a photo now. We talked about these as having potentially, let's see, for the hundreds of these that exist, we talked about these as being objects that circle the galaxy. All right, this will be 8 seconds at 6400 ASA. These are called halo objects, these giant clusters. As a whole, as these big clusters go, these giant clusters actually circle the galaxy. And when they circle the galaxy, they dip into our galaxy. They end up coming in contact with other stars. They lose some of their own stars. And they gain some, they lose some. So some of the stars that are in these clusters may be stars that have planets, but not from the very beginning. These were planets, stars rather, that were pulled into the cluster gravitationally as it made its way through the disk of the galaxy. Think of these as gigantic, gigantic battering rams. They come down through the galactic plane, swoosh, and just go wham. They go right through the galactic plane, and as they do, they cause all kinds of mischief. They cause all kinds of gravitational perturbations, you know, or alterations to the local gravity of all kinds of other objects in there. And they might lose or gain stars. And when they do that, for the most part, they keep their stars and they retain their stars. However, they do and possibly can have planets based on the fact that they might have stolen some stars from the disk population. So this is just an incredible, object to look at and to see. So these stars are they're very old. I mean, these are not young stars. They're, like I said, among the oldest stars in the galaxy, and they could actually be the oldest stars in the galaxy. And that goes for every single globular cluster, not just M13, Messier 13. So that is a really cool thing. This is a really pretty view of this tonight, I gotta tell you. I'll make this available on the companion site as well. I think you'd like to see that.
And for everyone on Facebook, I did put the link in chat.
Oh, great! Thank you.
It's the same as this channel. It's SkyTour LiveStream with Mark Antonio.
Okay, thank you. Well, now let's go someplace else. Again, on Astronomical Potluck tonight. Here we go.
And he is taking requests.
Yeah.
It's in Connecticut, so keep that in mind when requesting things. Can't see what's in Australia.
Oh, well, that's true. Okay, just a minute.
Not sure if Duplicate is still in chat or not. He was in earlier, but I wouldn't mind seeing the Cat's Eye Nebula. That was absolutely gorgeous, and shout out to him for recommending it a few streams ago. It was hypnotizing. It was so gorgeous. I think that's one of my favorites so far.
I'm liking it. I'm liking it a lot. Okay, now this, where I am now. Alright, we're gonna pull in something right there. I don't know if you can see it, it's right in the center. Let's go back to regular. Go to a regular photo. I'm gonna do a 13 seconds at 12,800. So it's a long time. So I apologize for the time. Oh, and I did have to plug in the iPad as well. Because the iPad was running out of...
I was going to mention that. I was going to say change batteries or do something before you hit stream, but...
Well, no, I can't change batteries in the iPad, unfortunately.
Oh.
Check this out. Now, this is a galaxy called M101. Now, this is an interesting galaxy because it's a spiral galaxy. You can actually see the spiral arms. The center, you can see the central core there of the galaxy, and then it has spiral arms that spiral out. You know, in a if you were to wind it up, it would be going counterclockwise. All right. So the spiral arms come out and go. You know. Well, there's several of them. There's 1, 2, 3, 4, 5, 6 spiral arms, and this is a face-on galaxy, so you're looking down right on top of it, kind of like a very, very faint hurricane shape. Now, it's 23 million light years away. So we're seeing this as it was 23 million years ago. This is incredible, you know, and it has a lot of stars in it, and I mentioned at one point in one of the streams that when we look at a face-on galaxy like this, we have a good chance of catching a supernova, something that could happen dynamically right before our eyes. And if we take another photo and come back to it, we might catch something, but they're not, supernovae aren't that prevalent, so we wouldn't really see them, you know, perhaps. But it is pretty cool. I'm going to take another photo, though, just because I want to, at 40,000 ASA for 20 seconds. It's going to be a little bit brighter, but I want to do this because I want to just see if we can get a little bit more detail in M101's spiral arms. This is also known as NGC, which stands for New General Catalog, NGC 5457. It's also known by the name the Pinwheel Galaxy. Alright, and it's in Ursa Major, and it looks like that was just a little too bright, but well, let me see. Might be able to do something. Let's see.
Yeah. It's so funny. Every time you have the camera on and you can see a few really bright stars, we wait about 10 seconds and just millions of them pop.
Yeah.
Every single time, I'm stunned. I mean, I know what's going to happen. It's not a surprise, but yet it is a surprise every single time. I love it.
Well, wait until we actually go into the Cygnus Milky Way and start playing, because we're going to do that as well. And we're going to just take some deep photographs of the Milky Way, so you can just see the immense, and I like the word plethora, of stars that we see out there. Now,
do you think the arms of the spiral have gotten bigger over time? Do you think?
I don't know if they've gotten bigger. I think that, you know, all the stars are orbiting the galaxy. You know, they orbit ours, they orbit that one, and so they do. They change perhaps, but we don't know what that change looks like. So here we go. This is another one. This was a 20-second shot at 12,800 ISO sensitivity, and you can see the central core of the galaxy. You can see the pinwheel shape actually a little bit more clearly. All right, and I love M101. It's really fascinating, you know, and you know, being 23 million light years away, it's pretty cool. And now, how do we know the distance to these galaxies? You know, that you gotta say, well, wait a minute. And you maybe it's just accepting it, but how is it that you know this distance? Well, we know that because we also discovered a relationship between certain types of variable stars. These are called Cepheids. And these Cepheid variables would have a certain rate that is a period of brightening and dimming, that was absolutely like clockwork. It was very regular for certain Cepheid variables of a certain brightness. At a certain luminosity, the Cepheid variable could almost be all but guaranteed to have the same period, that is brightening and dimming cycle. So if you know the luminosity of the star, or you look at the apparent brightness of the star as it appears in this distant galaxy, and you know the period, you know what the luminosity ought to be, and you just know, if you know the difference in the luminosity of how it looks in the galaxy and how it should be for its period, then all you have to do is consult a special table called the period luminosity relationship, and you can tell right away how far away it is. It's just the coolest thing. Now, certain things in the universe do work as planned and do work as expected, and one of them is this. These particular variable stars have a certain rate of brightening and dimming. So if a Cepheid brightens and dims over a period of 5 days, that corresponds to a very specific luminosity, that is an intrinsic brightness. And that luminosity is known, and thus you compare the luminosity as observed with the luminosity as it should be, and that tells you really exactly how far away it is. And that's something, if we ever get into some advanced astronomy or more advanced astronomy, we'll talk about it. It's called the distance modulus. Modulus, M-O-D-U-L-U-S. And so the distance modulus is something that will tell us how far away the galaxy is. Actually give us the distance of the Cepheid variable. And if the Cepheid's in the galaxy, we know how far it is to the galaxy. I mean, it's just so cool.
Did Edwin Hubble discover the Cepheid relationship?
I don't think Hubble did he? See the guy?
I don't know.
Yeah, no, I don't remember. I think it might have been. I'm trying to remember who else was working on it. The period luminosity relationship is something that everybody used, and I'm trying to remember who actually.
The Cepheid relationship.
Yeah, the period. Yeah, the Cepheid variable. Yeah, it's the same thing. Period luminosity relates to the Cepheid variables. And this works for stars in our galaxy, stars in distant galaxies, stars in the most distant galaxies. So it's really cool. All right, so this is M101, the Pinwheel Galaxy. It's gorgeous, absolutely stunning. I guess, you know, taking long-term exposures of it is really nice. And I think, oh man, let's see how far down that is. All right, well, let's try this. Now I'm going to try to do this other one. I know you were asking about the cat's eye, right?
Yeah, we do have some other requests from people in chat, though, so take them first.
All right.
Maddie wanted to see the Andromeda Galaxy.
Yeah, the Andromeda Galaxy is definitely on its way up, and we're going to be able to catch that a little bit later. It's certainly not going to go down. It's only going to get better as the night goes on.
Okay, I thought maybe we might be cruising by there. And Daryl wants to see NGC 4565.
Okay. So let me. Okay, first here, let me just take us to. This is a planetary nebula that's called the Owl Nebula, and it's in the same constellation. It's just a little farther down. And let's go there. Let's see if we can catch it.
And Maddie also wants to see Saturn. Don't know if we're going to do planets tonight, but...
Well, we did the moon, so how could I turn her down? Is Maddie female or male? I don't know.
I would assume male because it's a Y, not an IE, but...
Oh, how about that? I didn't even think of that. Well, Maddie will tell us. Like Matt, right?
Oh, that's what I'm thinking, yeah.
Yeah, okay. All right, well, let's, first of all...
Could be Matilda.
Oh, that's true. All right, we're going to take this photo. This is of the Owl Nebula. I don't even know if we have it in here, but it's a 4-second exposure. Oh, and we do have it. Look at that. 4-second at 102,000, and it's a little bit low, but we'll try. We'll see if we can make something of it.
And just for follow-up, Henrietta Swan Leavitt discovered the Cepheid relationship.
That's right. Very good.
Hubble used it when studying the Andromeda Galaxy to determine if it was another galaxy separate from our own.
Mm-hmm. Very good. See, that's what I like. You just go ahead and find these things, because I don't know all the answers.
We have such an incredible chat. We really do love you guys.
Yeah, I absolutely do. I just love being able to do this stuff for people that are intelligent. I really do. Okay. I really, really do. And I want to thank you so much for joining me each night when I do this. When I get to Arizona with this telescope, it's going to be a very, very different thing. We're going to be seeing a lot of objects very, very clearly. It's going to be beautiful.
Someone was asking if you were in Arizona yet. I said, no, not yet. Still in Connecticut. But so just again, Connecticut, keep that in mind when requesting objects.
This is 15 seconds at 8,000 ISO, and I'm trying to just get a nice view. The Owl is a what's called low surface brightness, and so there it is. And when you look at it, you can actually see this and I was trying to get it so we could see this, the very, very faint central star in the Owl Nebula. And that central star is the progenitor, that is the thing that caused it. And the Owl is a planetary nebula, and that is the remains of a star that has died. And so this is it's about 1,700 light years away, and its apparent size in the sky is 3.4 by 3.3 arc minutes. And if any of you remember that formula that I gave you, you can actually calculate the actual size in light years of this in the sky, and that'll leave that for you to do. I'm not gonna, go through that here with you now again.
I do have it written down somewhere, but I
sure
can't remember the numbers. 641
yeah,
278 or something like that. I don't know.
Well, it was 206-265 was in there, but don't worry about it. Now this, if you notice that in the center of this thing, the star in the middle is sort of it's faint, but you can still see it, and it's actually a very, very very, very faint star. I can't really make out too much of it right now. Actually, I'd have to go longer, but I think I want to serve the folks that want to see the cat's eye. I want to make sure it's up.
Well, that was just me.
Oh, that was just you?
That was just me. But Duplicate is in here too. He gave me a thumbs up, so.
Okay. Well, then Duplicate wants to see it too.
Probably.
All right. And let me see if I can find it. You'll notice it's a lot quieter outside. That's because the construction is not occurring right now. Yeah. Let's see where it is. Okay. And now we'll go to the cat's eye. You can't see it yet. Not because I won't let you, but just because. Okay. Now that we're here, let's take a photo, shall we? And this may be too long, but we'll do 15 seconds at 8,000 ISO one more time, as before. This is actually very, very high in the sky right now, so it's very favorable, let's put it that way. We could play with this one to get it just right. And as the moon is setting, the sky is going to get darker. Alright. Now you saw it there. In fact, you can see it, even right now you can see it. It's that blue thing just to the lower left. And I'm going to center it, okay? And then after I center it, I'm going to see if we can... Okay. Alright, now it's centered. And if I zoom in on it like this, wow. You know, it's kind of cool. I didn't expect it to be so nice. Whoops, I don't want to take it too far away.
Like, I don't understand why I find this one so particularly mesmerizing. Like, is it closer than most of the other ones we're looking at, or?
Oh no, this is 3,100 light years away. This is not close by any stretch. And you know what? Distances to planetary nebulae are not well known. But let's try and change some parameters here. First of all, that was 15 seconds we did earlier, and 15 seconds got us this guy. Whoops, sorry, this guy right here, which you'll see when I bring us over. Okay, that's what gave that's what gave us that's what we got for 15 seconds. This is it's not the brightest planetary in the sky, but it's actually bright enough that 15 seconds is way too bright. And of course that's at 8,000. But let's go to 4 seconds and go down to
Is it the materials that make it seem so much brighter, like, or is it just me? Maybe it's biased because the word cat's in the title. I don't know.
I'm sure that's what it is. But it's actually a compact object too, Amanda, so it's a very compact. So this is 4 seconds now. So at 4 seconds, what do we got? We have wow, look at that. Now when you look at this, check that out. You actually see the fairly convoluted structure on the outside, and you see that white central star. That is the progenitor of the star that has died. And you say, well, wait, if it's dead, how come we see something in the middle? That's the stellar core left over from the sloughing off of the material. And that's what we're seeing there. Oh, I see Milky Way too. So this is the Cat's Eye Nebula. All right, and when I upload this for you, you'll be able to zoom in even more than this. And if I went to the screen, and we could do the zooming on the screen, we would see it. So it's fine. Now let's see. That's actually pretty good. So that's really good. Okay, so Cat's Eye Nebula came out pretty good, and it's even visible. But look how tiny it is right there. It can be mistaken for a star. You know, and this is NGC 6543. Now, what did Daryl ask us to show? What do you want to see?
Daryl wanted to see NGC 4565.
We want to see NGC 4565.
4565. Yeah.
Okay. All right. Well, let me see now. Okay.
So, and you might have said it. I was trying to follow chat as well. What's the red one to the right called?
Oh, that little star.
Mm-hmm.
It's called that little star. No, it's just it's actually a star right near the cat's eye.
It doesn't have a name. Why not?
No, it doesn't have any particular name. It has a designation, I'm sure. You know, there are many different catalogs. There's HD catalogs. There's SAO catalogs of stars. AAVSO for, you know, variable star observation, things like that. And I don't know what that particular star is, but there's many of them out there. You know, when we actually look, if we go to the view here, let me just go here again.
I mean, it was so bright and so close. I'm surprised it wasn't investigated enough to have a name.
Oh no, it is. I'm sure it is. I just don't know what it is.
Oh, oh, okay.
Yeah. There's a live view. That's the live view of the cat's eye. Really pretty. I just love that.
It just pops right off the screen. I love it.
It might have something to do with the fact that you know. It might have something to do with the fact that you're you know, like cats. You know.
And blue is my favorite color. It looks very, very blue.
Well, that.
I don't know if you consider green or
that would
what color you consider it.
By the way, 4565, just so you know, Daryl, it's behind my house, so I'm not gonna be able to see it. It's far on the western horizon right now, so we're not gonna be able to see that, unfortunately. The moon is very low in the sky, and Andromeda is coming up, so we have a few more things we can see. And what I'd like to do, actually, is take us to some of the more obvious items that we can see that are cool.
Will you be able to see 4565 at all this year?
No. Well, yeah, we already did. Unfortunately, we're not going to be able to see it anymore unless we went at it early in the evening. You know, we should have gone a little earlier, maybe. That could be my fault. Alright, now we're going to go and swing the telescope around quite a bit to go to this next object. Alright, moving. All right. Does anybody know what that is yet? Anybody have an idea?
I am only seeing a few stars on my screen because I'm behind.
I know.
Okay, just...
And everybody, they all know that. Fine. All right.
Give them 30 seconds. I just asked.
Yeah, no,
Chat, what are we looking at?
Yeah. Well, by the time they hear me say it, they're seeing it. So, you know, that's not a big deal. Okay, I'm gonna actually increase.
I was gonna guess that.
What?
Is it gonna be Saturn?
What do you think? What do you think?
I don't know. I'll guess when I can actually see it on the screen.
Okay. Yeah, we're gonna we're going to be going to see Saturn here. Yes.
Yeah, see, we had 2 guesses for Saturn.
Yeah.
We had a guess for Jupiter. Oh, 2 guesses for Jupiter.
Okay.
Because they think they see 4 moons.
Well, actually, why don't we zoom in?
Is it one of the very outer planets? See a few moons near it too.
Right.
See, I mean, right now I see something big and white and bright.
Yeah.
With a whole bunch of... See, oh, wait. It just zoomed in.
Okay, I have it overexposed right now just so you can see the moons. Yes, this is Saturn. But if you look, I want to show you this because check out to the right of the blob that is Saturn, the elongated egg-shaped blob that is Saturn. You see the 2 little tiny dots?
I do.
Those, the left dot, the little tiny dot, is Tethys, and the right dot is Dione. And the upper right dot there is Rhea, R-H-E-A. And Mimas is actually in the glow to the left of Tethys. So in line with Dione at the lower right and Tethys at the slightly upper left, along another line there is Mimas. And I don't know if we can see that. Now, also, out to the left side of Saturn is Titan. Okay, and that's a fairly bright one that you can see there. And Enceladus is I think lost, just barely lost in the glow, just to the left of Saturn. So why don't we go see if we can pull something out of this while we're here. And I know P and K do this very well, but we are a deep space telescope, not a planetary telescope typically, and it does make a difference. So now you can actually see.
Yeah, because Steve... Sorry, go ahead.
I'm saying now you can see Titan on the left. You can see Tethys and Dione, the 2 closely spaced ones to the right, and you can see just above to the right, you see Rhea. Very cool.
That's very cool.
Now I'm going to come back out and just bring this down to a usable brightness.
And Steve wanted to know if you've ever streamed Uranus, Neptune, or Pluto.
I have not. I know Paul's got...
Uranus doesn't seem to get a lot of coverage.
Mm-mm.
How many moons does it have?
How many? What's that?
How many moons does it have?
How many moons does Uranus have? Well, let's see. There's Umbriel, right? There is... let me see. I don't know. I have to look that up. I don't know. I was wondering. I was noticing I was losing my red light, and I was wondering what's going on, and I realized, oh, well, the bulb in my red light was loose, and I had to tighten it. Dummy me, you know.
And
okay.
Just your hands so you don't burn them.
Right. Yeah, that's fine. It's a small light. So Saturn's a little bit low. So it does kind of have a, a shaky look to it, but it's still pretty no matter what. And I'm not using any kind of a Barlow lens. That's a lens that actually makes it look much more, bigger. It doubles the size of the view typically, and I'm not using one of those. But that's Saturn. And what was I just talking about? We were talking about another thing just now. Besides Saturn, what were we talking about?
Steve wanted to know if you streamed either Uranus, Neptune, or Pluto.
That's right.
And I asked about the moons.
Right. Let's go and see. Let's go see what we can.
And P&K got Pluto one day. That's really nice.
Yeah, I remember that. It was beautiful.
Mm-hmm.
Okay, that's not going to work. That's below the horizon. Not what you're asking for. Hold on. Let me just see what's going on here.
See, I was going to say it's gone again, but with the 30-second lag, it's not going to make any sense.
It's green.
Okay.
It's all green for me. Okay. Let's hope it was just a momentary glitch.
Just a little glitch, yeah.
Nothing could go wrong. Go wrong. Go wrong. Go wrong. Go wrong.
Hi, NSA. I love you.
Oh, as if. Let's see. So what do we got here? How about... Alright, well... Let's go here and see if we can see it. I'm moving, as you could tell. Wow, that's low. It's so low I may have to duck. Maybe not. Maybe I don't have to duck. Let's see if I can show you this here. Just a segundo. Very low, but that's Neptune. That's very low.
Waiting for it to zoom in.
Yeah, sure. That's funny because when they hear you say that, they're like, well, what's he talking about? It's already there on the screen. Alright, yeah, there's Neptune. Now, it's really low, so it's not showing any of the characteristic blue color that you would expect to see, actually. And that's too bad, but don't worry. It'll rise. It's on the eastern horizon, so it's rising. And if we zoom in,
I think chat knows what's going on though. When I okay, gone. Okay. Yeah, when I'm 30 seconds behind seeing it, I think they understand.
oh no, they
the
do.
problem is on my end.
I'm being funny.
Trying. Sorry, you left yourself open. I couldn't resist.
I'm okay. It's fine. Believe me, that's not the worst thing I've heard. Far from it.
Do you know how many moons Neptune has by chance, offhand?
The moons of Neptune. Oh, let me see. Do I know how many moons Neptune has? I should.
Because again, it's something that I never really think about, or never had really thought about before.
Yeah.
And then when you hear there were 67 now, possibly, well, no, it's confirmed now, there's 69 for Jupiter,
Yep.
and that seems to be like a common fact. I figure, okay, well, everyone should know, well, astronomers should know how many moons each planet have, just because.
Yeah.
And I had no idea Mercury and Venus did not have any moons. I seriously found that out a few months ago.
Wow.
Just because it's something I never thought about, right? I mean,
Yeah.
why would you look it up when you never think to, right?
Yeah.
So, it's fascinating. It's crazy.
Yeah. Well, see, Neptune has actually 13 moons.
13?
Yeah, and among the biggest ones are Triton and Nereid. Triton is a fairly interesting moon. And we actually saw these pictures when Voyager 2 went by and got very, very good photographs of them. Very, very good photographs. There's a beautiful photo that you can look up, I think, and it shows Neptune in the distance, and you actually see Neptune's moon, Triton, in the foreground, a blocking part of Neptune. And it's a real photo. It looks like it's something you'd put together, but it wasn't. It's actually a real photo. And then Neptune also has a ring system. It actually has these two fine rings that are almost black. They're almost black. It's really, really cool.
What are they? Are they like the pieces of rock going around Saturn?
Well, they're like that. I mean, they're similar to the rings around Saturn, except they're made of a dark, carbonaceous type material, dark carbon black type material, which is really cool. And I absolutely love this. This is just very cool. So, that said, I think it's really neat, and we're gonna probably look at and see.
Is that as close as you can zoom on it?
Yeah, that's zoomed in. It's fairly small. It looks like this in the sky, which is tiny, and so one level in is there, and next level in is there. So the slightest touch of the telescope makes it bounce around, but you'll notice the colors. You see little red, little blue. That's actually induced by the atmosphere, and and you see planets don't generally twinkle at all, but when they're low on the horizon like this, they will seem to shift colors. All right, which we can actually see if I do our technique, which is kind of, I'll see if I defocus it.
I was just about to ask if you could do that.
Yeah,
that's funny.
And check out the colors of this. All right, by defocusing it, look what we got now. All right, you're gonna see now a very different Neptune. Okay, check this out. It looks like an art piece. See? Now, that is what we see as a result of the atmosphere, basically getting in the way of the light coming from Neptune. So we don't actually get to see Neptune the way it should be seen, because obviously there's so much atmosphere, because we're looking along the atmosphere at Neptune right near the horizon. And this is what you get. Isn't that cool?
That's gorgeous.
Yeah, it's like an art thing. And if we can defocus it a little more. All right, and the donut, of course, is the artifact due to the telescope type. But you can actually see this really neat color scheme, and that's actually the light from Neptune being broken up and scattered, and other rays nearby that are from other parts of the white light that are coming from Neptune being broken up into their spectral components. And what you're actually seeing is something called atmospheric scintillation. And scintillation, it's spelled S-C-I-N-T-I-L-L-A-T-I-O-N, scintillation. Atmospheric scintillation is this right here. You're looking at it. And because Neptune is not a point source like a star, when it's focused, which is it's not now, but now it is. Okay, when it's focused, you don't see the scintillation as bad, but you only see it when it's actually defocused like that. So planets can show scintillation; they just have to be defocused, and that's what we're seeing here in that. So maybe when Neptune comes up a little more, it might be a little better, a little easier to see. But I do want to take us up to the Cygnus Milky Way right now. And yeah, it's almost anywhere we go is going to be beautiful up there. So let's go take a look.
Okay, was
Yeah, go
Now,
ahead.
I'm gonna mix this up so badly, I can tell already.
Oh, nonsense.
Was the word scintillation?
Scintillation.
Scintillation.
Sin
Is that
T with a T. Scintillation. So it's SCINT. SC together kind of makes people think they got to say sk, but it's not. It's sin. SCI is like science. Scintillation. So it's a weird name, but it's exactly what it is. Okay.
is that what causes the atmosphere to look multicolored on Jupiter? Or is that something totally different?
No, actually, the Jupiter's colors are real. This is induced by the atmosphere. The colors that we see at Jupiter are due to the ammonium hydrosulfide chemicals in the atmosphere. It's actually Jupiter's made mostly of hydrogen, and the thing is the hydrogen gas in Jupiter's atmosphere has just the tiniest little bits of pollutants in it, and these pollutants actually cause Jupiter to actually have the colored cloud bands. It's really cool. I'm moving now, by the way. I'm going to go up to the Cygnus Milky Way. Cygnus is right overhead. And we're going to just explore the Milky Way for a bit, because there's so much to see after I refocus the camera. When I do the defocusing thing, obviously it can cause us some problems, as you can see. So I'm going to
something here.
What?
I'm just gonna check something here.
Sure. It is your prerogative.
Okay, no, very interesting. No, our friend Steve here in chat said, because Daryl was kind enough to spell that word for me.
Yeah.
And I said I figured he would. And Steve just mentioned impaired that it helps seeing the written word. I know Tana is as well. I actually just went back and checked one of Mark's previous streams. I had it on mute, and I pressed closed caption. The words do come up.
Awesome.
So I don't think they will on a live video, but do please go back if you want to double check anything. Not sure how the spelling is going to work. I'm assuming it's all automated by YouTube, but please, it is functional. It is working. These videos are closed captioned, so check that out. Yay, that's awesome. That's really good. Sorry, PSA. Go ahead.
Oh, wow. Can you write Keith and say thank you? That's wonderful. And I'll tell you what that's for in a minute. Mark says that's wonderful, Keith. Thank you.
Okay.
And I have to just get back to here. I want to show you something now. I will share. I'm going to tell everybody what is so wonderful about this in a sec. First of all, let's do a ISO 2500 exposure at 2 seconds of the Cygnus Milky Way in this particular region. Alright. Now, this is a cluster of an open cluster of stars. Now, when stars are born, the stars are born typically in clusters. Why? Because that's where there's concentrations of gas like hydrogen that is the fuel for the stars, and the hydrogen gas is found typically in knotty clumps and clusters that are throughout the galaxy. And when stars condense and coalesce from these, it's not just one that forms, but many all at the same time. And this is a cluster called Measure 29, and M29 is not very, it's not really elaborate by any stretch, but it does have a lot of stars in it that are, that are interesting. And I'm going to just up the exposure now to 8 seconds, staying at 2500 ISO. When I say ISO, that means sensitivity. So there's an 8-second exposure now, and let's see what we get. And you'll notice now that we're seeing that there are many more stars available and that are visible. And you know something? We're just scraping the tip of the iceberg here. Because if I take this photo now and come back out and increase the ISO setting to 5,000 and go up to 10 seconds now. We're going to do a 10-second at ISO 5,000 exposure of the Milky Way and Cygnus within Messier 29. You're going to see yet more stars. And you'll notice that it becomes more than just more stars. You start to see that there's really clouds of stars. There are clouds of stars that are literally filling the view, and that's what we see. Isn't that crazy? That's amazing. So this is...
See, things like that with an astronomer, where do you even begin? How do you pick which one to, you know?
Oh, well, every one of those stars has been studied, you know, at one time or another, you know. And let's go, while we're here, let's actually go over to, oh yeah, this music is really good for this too. I like this. Alright, now we're going to go to another location, and this is...
So what section is this called that we're on right now?
Well, this is near Messier 29. It's near the I should say the Swan's. It's near the Swan's head, basically. It's actually near it's sort of not near the head, kind of near the center of the Swan.
The Swan being Cygnus?
That is correct. Now let's do a 10 seconds at an ASA 5,000. Huh. I think this is funny. There's somebody pulled up my driveway, and they got halfway up the driveway, and they realized, oh, I think this is the wrong house. That was funny.
What must they think of that dome?
Well, that's the thing. The dome is facing them, so they can actually see something going on in here. I'm not sure.
Can you imagine? You pull into the wrong driveway and you see... If you didn't know what it was, and what, it's 11:15 there, it's got to be pretty dark in the driveway.
Yeah, and there's this red light coming out of the dome.
Yeah. And something, if you didn't know it was a telescope, I mean, it should be some kind of a weapon aimed at them, aimed at the driveway coming up.
That's right. And they better keep that in mind. No, I'm just kidding. That's funny. Okay, okay, so right now, we are over an area in Cygnus that's called the North American Nebula. Now, I haven't done any exposures to try and bring it out. We haven't done anything beyond just check it out. But I'm going to go up to 12,800 and an exposure of 15 seconds. Now, when I say I'm going to kick off an exposure of 15 seconds, I press the button. And what happens is I have a 2-second delay on the start of the photo, because that gives it time to actually calm down and stop shaking, because there might be some camera shake induced. Okay, so now let's take a look at what we see. Yeah, see, now we're starting to see, and we're actually inside the nebula, so to speak. We're actually zoomed in effectively, so the nebula is like literally all around us here. There's nebula everywhere in this image, but we can't really tell. You can tell by the cloudiness. That milky whitish color that you're seeing is not because of the moon. is out, because the moon is actually fairly low in the sky. This is actually what we're seeing from the nebula itself. And I want to take us a little bit higher in ISO one more time. We're going to go to 25,600 ISO and 15 seconds and see what we get. Again, we're inside the North American Nebula within Cygnus, which is a star-forming region, which is a H2 region, that doubly ionized hydrogen region I told you about, which is a birthplace of stars, a stellar nursery of sorts. And this is an area that is made of the mostly hydrogen and hydrogen gas, and it's a very rich area of the Milky Way, as you can see in the photos. You know, we've got a lot of stars in this image. In fact, the milkiness you see in that photo is not, again, due to the moon, but because we're seeing, along with the nebula, we're seeing stars. And the stars aren't just the points of light. The stars are sometimes these subdued, these very subdued clouds that are just clouds of nebular, clouds of stars instead of nebula. I kind of stammered that out. Sorry, I was moving and doing 4 things at once. That's what happens when you're running an observatory. That's pretty cool.
Multitasking.
Yeah, it's kind of crazy.
Maddie had a question. It's a good question. I think you've touched on this before, hence you wanting to move to Arizona. But are you in an area with low light pollution?
Well, with the moon out, no. But generally, if the moon is not out, then I could have some very nice views. I can see the Milky Way starting in Cassiopeia, and I can see the Sagittarius star cloud at the other end toward the south. But we have what's called light domes. These are the encroachment of light from nearby cities and towns. So it's not perfect, but I do have a fairly nice sky. And I might have said this to you guys before, but I will always, before I buy a home, you know, I've done it 1, 2, 3 times. 3 times. No, wait, 3? 3. 3 houses I bought so far in my life, you know, consecutive, because move out, move in, move out, move in. And what I've done is I have gone to the house at night, and if I can see the Milky Way, then I will consider it. If I can't see the Milky Way overhead, I simply won't buy the house. Is that sick or what? My sky determines whether I'll buy a house or not. Is that something? I'm nuts. I'm crazy. All right,
and your wife loves you a very great deal.
Well, don't jump to conclusions. All right, here we are.
Well, I'm assuming she went with you for all 3 moves.
Yeah, well.
Steve wanted to know, have strangers ever asked what your dome is?
Yeah, I tell them it's a porta potty. No lie. Oh, I say it's a big porta potty, and I just let it go. And you know, they'll sit there and go. One guy actually said, "Oh, wow, well, to each his own." And I had to laugh because, you know, then I had to say to him, I go, it's not really a porta potty. I said, it's a naval facility. Don't get too close. And I just stopped there, and he was like, oh. And I said, no. I said, it's an observatory. I went and opened it up and showed him, you know, this gigantic telescope towering over your head when you're in here, and this computer and everything with everything going on it. And he was like, wow. That's incredible, man. That's crazy. I go, well, it's something, isn't it? I don't know what it is. Okay, I'm taking a photo.
And how many of them ask you, can I come back one night when you're doing a star party or something?
Every single one of them.
I don't doubt it. I don't doubt it.
And the other night I had 25 people here, actually. And we were doing a star party. I did stream that, if you noticed.
Yeah, you can go back and check that out, actually.
Holy cow, that's just amazing. Oh, okay, oops. I almost yanked this out of the wall. I was so excited. Okay, I I went to a little farther down, just below Cygnus, a little, not too far, and I grabbed the Dumbbell Nebula, which is just stunning. It's a little bit out of the picture. I'm going to bring it up. All right, I'm going to take another picture of it. Hold 1 second as I do that. Oh man, this was just beautiful. I did 15 seconds at 12,800 ISO. Okay, and if I do that, and by the way, how is everybody doing okay with my voice volume? Am I not too soft? Is Amanda not too loud, not too soft? I mean,
some. I'm always too loud. Someone asked if you could turn your mic up way back. I'm not sure.
Which one? Turn my mic up?
Been interested or not. Turn your mic up, yeah.
Oh, well, I can actually move it a little closer.
Yeah.
Or I could talk louder. I'm able to do that.
Yeah, and I missed a question from the picture before. So when we're done with the dumbbell, can we go back? Or can you even go back to the picture?
Yeah.
Rather than
moves.
Okay.
Yeah, I think so. I took a picture.
Yeah. Okay.
Dumbbell Nebula, remember, is a planetary nebula. It's a remnant of a dead star. And the physics that goes on inside of these types of nebulae is really impressive. And what I'd like to do is just talk to you a little bit about it. I'll take another photo, and then we'll bring up the photo once it's centered. The Dumbbell Nebula is, and just to give you let me just give you the stats on it first, because that probably would be helpful, huh? Instead of just talking about it to tell you how far away it is and all that. It's 1,400 light years away, all right, and it's 8 by almost 6 arc minutes across. Okay, so 1,400 light years away, 8 by 5 in arc minutes, and you could figure out the size in the sky in light years if you want. Now, here it is. Here's the dumbbell. The central star is very brilliant right there. This is something that shows that what the night is. The night is, we have what's called good seeing and good transparency. It's a cooler night. I'm actually very cold in the dome right now, and it's summer, for crying out loud.
I saw the hood go up, actually.
Yeah, okay.
The things you do for us, thank you. We appreciate it.
I'm just crazy. So when we look at the dumbbell now, we're actually seeing it's very crisp and clear, and I'm really excited about this. It's looking so good. And as we zoom in, you can actually see some extremely well-defined, knotty, gas areas on it. And the reds are due to hydrogen gas emissions, and the blues are oxygen and potentially some helium. And then that central star, right in the middle, very faint, is the progenitor. That is the thing that caused it. And I actually find the dumbbell to be just stunning. And I want to do one thing here before we go on. I just want to confirm my focus here, okay? So I'm going to move us over just a little bit. Move us over just a little, and I'm going to get a star in here that I can focus on really well. Or two, there we go. Alright, and now I'm going to focus on those, and then I'll move back to the dumbbell carefully. There we go. Me like a that. Me like that one. Sorry, I think Jar Jar Binks was the worst character in Star Wars ever.
I just heard a theory that he was the strongest Sith Lord in the entire universe.
Yeah, I think that was the strongest April Fool's joke ever, too.
It was a good theory.
Okay.
I love crazy conspiracy theories like that.
Okay.
Eh.
If y'all say so. Okay, I just did a 15-second at 12,800 again. And I think I got... But I want you to notice that not just don't look at the dumbbell alone this time. I want you to actually look at the area around it. Look at the sheer number of stars that we can see. All right. All right. So I'll take one more photo. Okay. Again, 15 seconds at 12,800. The dumbbell nebula. That's Messier 27 in the constellation called Vulpecula. And Amanda, remember what Vulpecula was?
A little fox.
You got it. Very well done.
Haha.
And while we're doing this...
Is it Latin by chance?
Oh man, you're asking me. It might be Arabic. I don't know. But while we're waiting, I would like actually for you to give us the astronomical facts for the day, for tonight. Would you like to do that?
I could. I was actually gonna give the fun fact that a Vulpix is a really cute fire Pokemon, and he looks like a fox. So
that's funny.
That's why I know Vulpexia.
Vulpecula.
Vulpecula.
Mm-hmm.
Wow. Okay.
Isn't that a stupid name though? Vulpecula. What the heck? Don't swear at me. What's a Vulpecula? Very cool. Oh, look at this. Oh man.
Well, it's the same thing. There's a Pokemon that looks like a bear, and it's called an Ursura.
Oh, and that makes sense.
Yeah. So I mean, it does make sense, and
Yeah.
I'm sure there's a lot more space related, but now, okay, my mind blanked. It's, for some of us, still the 29th, July 29th. For some of us, it's the 30th. The 29th of July, is this not the day we landed on the moon? Am I off by a few days?
You might be right. I actually don't know.
Because, I mean, well, I just found, like, some space history. I didn't really go through it. I just kind of scroll through to see if there's anything interesting, but I looked at the date and I'm like, July 29th. I'm sure that today is the day we landed on the moon, so it was a very fitting way to start tonight's stream on the moon.
Yeah.
We have a bit of chat, a bit of conversation in chat. Is it too late to see the Pleiades?
No, it's too early to see the Pleiades.
Or too early?
The Pleiades don't rise until way later on, because Pleiades are a winter constellation in the constellation of Taurus. Actually, not constellation, or asterism within the constellation of Taurus. Remember, an asterism is a pattern of stars within a larger constellation, and that's what that is. So, yeah, and they look like a kind of a little dipper, which is neat, you know. So,
okay.
Go ahead.
I'll give you some of the news.
Yeah, please do, because I'd like to hear it. And while we're, as a backdrop, we'll look at the dumbbell nebula here.
Yeah, you can have a raspberry Snapple break.
Well, I mean, yeah, yeah. And a nice Snapple
now
break.
there's some names here I'm not going to be able to pronounce, but it looks like a few people of import were born today. One of which worked on Sputnik.
Very good, Sputnik.
Is Mikhail Tikhonov. Sorry, he was born in 1900. I don't know.
Well,
Bible the Dead.
That's okay. I mean, you can be forgiven for not knowing how to pronounce a Russian name. I mean, it's never easy, you know. It's difficult at best to sometimes figure out what Russian names are. So.
In 1901, Florence Barnes was born, and they were an air racer, a Hollywood stunt flyer, and pioneered new air routes into Mexico.
Wow, that's pretty cool.
Yeah. And Melvin Day, who was born today in 1923, worked in NASA and the AEC.
Mm-hmm.
So, seems like, I don't know, is today symbolic for things to do with space?
I think so. I mean, considering that, you know, everything we look at, and in fact, everything we're looking at in our sky is an object in deep space, other than the moon. The moon's not deep space. But I think it's pretty cool. What else we got?
In 1950, there was a test mission. Bumper number 7 was the second missile launch from Cape Canaveral.
Really?
It was to be a maximum range test of a 2-stage vehicle to study the problems in staging.
Wow.
The launch was delayed because of moisture in the vehicle, but when it finally launched, the WAC achieved the highest sustained speed in the atmosphere to that date.
Wow, that's pretty cool.
52, the first Raccoon launch attempt. It's a balloon-launched rocket.
I thought you were going to say
launched from iceberg.
The first attempt at launching a raccoon. I was going to say, wow. I've seen when my father was alive, he launched a raccoon one time, but it wasn't quite the same way. But it's not that at all. You're going somewhere totally different. So you're saying that was the first icebreaker launched balloon?
Yeah. First Raccoon, which is a balloon-launched rocket, was launched from Icebreaker Eastwind off Greenland.
Oh, cool.
By NOR Group under James A. Van Allen. I know that name.
You should.
It was a low-cost technique that was later used by ONR. I'm not sure what that is, though, do you?
Office of Naval Research.
There you go.
I've worked for them.
And, well, see, stories you could tell us there, or things have to kill us.
No, not at all, but I can't say everything. But, yeah, I worked for ONR before. I did some jobs. But anyway, go ahead.
Yeah, no, it was just a low-cost technique used by the ONR and University of Iowa research groups in 53 to 55 and 57 from ships in sea between Boston and Greenland.
Awesome. Very cool.
1955. See, I'm just going through these now. I don't know if all of them are going to be interesting story. Tell me what you guys think of this, if this is boring, if this is interesting. 1955. Eisenhower approves Earth satellites for IGY.
IGY?
IGY.
And do you know?
I'm not sure what that is, though.
Well, you've got to
endorse the IGY proposal for the launching of small Earth-circling satellites.
Well, maybe someone in chat will know what IGY was. It probably stands for, like, it's IGY as in Y as in Yahtzee, you know?
Why? Because I love you.
Oh, I get that. I know what that is.
Disney's gonna sue us now.
The Musketeer Club. MICKEYMOUSE.
Oh, now we're definitely gonna get a copyright hit.
That's okay.
IGY. I'm not sure what that is. I can find out.
Okay. That's okay. Tell us more facts. We'll get there.
Okay. Well, someone will find out. Okay, it looks like Eisenhower was busy that day. He also, same year, 1955, announced that the USA would launch 10 kg satellites in 1958 without the use of military missiles.
That might have been International Geophysical Year. IGY.
It is. I should have kept reading. Okay, the president announced that the United States, as part of its International Geophysical Year contributions, would attempt to launch a number of 21-pound satellites without the use of military missiles. The project, named Vanguard, although organized in the Department of Defense under Navy management, would be completely removed from military significance.
Right, and they launched them with giant slingshots, but they crashed into the next town over, killing 17 people. Well, you know, not everything's perfect.
Some of the news may be fabricated tonight.
Yeah, just a little bit, I'm sorry. Just a little bit.
57, Air Force presentation on space capabilities and plans.
Yep.
Boring. I'm waiting to get to the 60s because I want to see it.
Well, you know what? Why don't we can just stop there, and you can pick the best ones from like 40s, 50s, 60s, 70s. You know, in future episodes, we can just do.
Well, that's what I'm gonna do. Yeah,
then
if I have a bit of warning, I'll find the best ones.
Oh, but I told you at least 15 minutes before we started that we were gonna do this. Yeah, I know. I know, my fault. I didn't give you enough warning. But it did give me a chance. I
could have been ignoring you for those 15 minutes and be reading this.
Well, I gotta tell you, I really appreciated it because it gave me a chance to actually sit down. and I was able to sit down and relax for a couple of seconds, which I generally don't get to do. And
that's kind of why, you know, I think it might be a good idea just to give your voice a break for a second. Like,
yeah.
I mean, you're just go constantly,
I
and
just can't
you
help
know,
it. This is
he's doing stuff before the stream, he's doing stuff after the stream. Just because the show starts and stops doesn't mean he's not going crazy in between, right? So
yeah, no, that's okay. Let's see, I'm even going to the next object right now. Here we go.
there you go. He's on it.
Yeah, and this is going to be cool. You're going to like this. We've seen this before, but the current location and the setup, everything, this object is going to be beautiful tonight. And I'm going to just, I got to put down the controller for 1 second. Let's go see if I can grab us a little photo. I'm really impressed with how these are looking tonight. So, and I don't have to do too many seconds here to figure this out. Here we go. Let's see here. I'm gonna do 6 seconds at 12,800. I can't even see it in the view yet, so it may not be in there, but I'm pretty sure it is. And I was right. Okay, there it is. I'm glad I was right because I didn't want to have to go hunting for it. There we go. So let's bring it up a little.
I'm just going back through chat now. Correction, July 20th was when we landed on the moon. The 21st was when the walk happened.
Yeah, that didn't sound. That's why it didn't sound right to me. And I was just like not sure, so I was just trying to beg off, trying to sound like a smarty.
No, but I don't remember hearing the anniversary last week. Usually that comes up like, oh, it was so many years ago today that. I mean, not that I watch a lot of news or anything, but I thought I'd see it posted somewhere on Facebook or something, you know?
Yeah.
So then I saw the date, and I figured if it wasn't today, then I must have just missed it. So thank you, Chris, for that.
Thank you, Chris.
Jeff wants to see the Veil Nebula. He said it's right there.
It's nearby. I will try to find that. I was actually waiting for it to climb a little bit more high, but it's pretty high now. This is M57, the Ring Nebula. We've seen it before, but again, it's a planetary nebula. And I just want to kind of reinforce my model for how I think this formed. If you have your hand in front of you and you actually turn your hand, have your hands in front of you and turn them sideways so that you're looking along the edge of your hands. That's the edges of the nebula. You can't see through your hands to the other side. Now, if your fingers are slightly spread apart, then, like as if you're circling a grapefruit that's in front of you, that's an invisible grapefruit, as you go around the back side of the grapefruit, you'll see that you can see through your fingers, okay? And then as you come back around the front as you circle around this invisible grapefruit, that you can actually see through your fingers again, but at the side you cannot. That's what we're seeing here, potentially. It's possible that we're actually seeing a thinner cross-section of gas on the front and back sides, but on the edges it's thicker, and thus we're seeing through more stuff, and so it looks more opaque. Now, this is a interesting nebula. It has a lot of features that some of the mathematicians and some of the theoreticians are actually thinking that this nebula has actually got a very different shape from what we've thought about traditionally, and that maybe it's coming at us and going away from us, and that we're kind of looking down a tube. I understand the research, why they say that, and this is a 13-second at 5,000 ISO shot, just to get it back. I understand why they say that, but I don't actually subscribe to that. I think that it's actually a sphere. And it's a sphere that we haven't, a sphere that has a fairly spherical shape too. Now, nebulae, like planetary nebulae, are also what we call bipolar. It doesn't mean, like I said, that they get angry with you and then they're happy with you, and then angry with you and then happy with you. But it means that they actually have these lobes that come off the north or south side, or the equatorial sides. They go straight out and cause these extensions. And if we look at the Ring Nebula here in this close-up, you can see there is one to the upper left and to the lower right. So it's possible that the Ring Nebula is also a bipolar nebula, even though it looks roughly spherical in shape. And that spherical shape is due to the fact that the gas came off in a relatively homogeneous manner when it sloughed off in the outer layers. Planetary nebulae to me have always been fascinating, and there's so many of them in the sky that you could just never get tired of looking at them. And you'll notice that a lot of them are blue. A lot of them have these blue colors. And I encourage you, look up, in Google, look up, why do planetary nebulae look blue? Or why are the colors of planetary nebulae blue? Or what are the colors of planetary nebulae? Look those up in Google. And I'm sure some of you out in the chat are actually doing that right now. And you'll find out. If you check out, now if we look at this image, look at the central star. That central star is very, very faint. Yet here it is. We see it. It's an exceptionally good seeing tonight. And we rate sky by seeing and transparency. And I said before that we have both tonight. The sky is seeing is good, meaning we have a fairly turbulence-free sky. And the transparency means that the air mass, that is the air between us and our objects, is fairly stable, and it's not causing any obscuration and alteration of our object. So we have good seeing and good transparency, and that is worth a bundle. That's huge. So I'm going to take one more photo, and we're going to try and drop the ISO down to something like unheard of 1600 for this, and we're going to go up to a 25-second exposure and see what we get of the Ring Nebula. Again, Charles Messier made that catalog of like 103 objects, and he just wanted to make sure that you didn't mistake it for a comet, or because so it was basically objects to avoid. But what an object it is, huh? What an object it is.
It's gorgeous.
Yeah, the Ring Nebula is a very interesting planetary nebula for us, and it's got to be about 1,400 light years away. And at 1,400 light years, it's fairly large in the sky. So let's take a look at it here. Wow, that's really pretty. I've been out here at night, and there's been times when I couldn't see the central star very well, because you look at how delicate that is. It's a tiny little pinpoint, 1,400 light years away, but it's a tiny little pinpoint. And most stars, in fact all stars that we see in the sky, other than the sun, are just points of light. We can't see the disk shape as it would appear to our eye if we were closer to it. And that's because they're so far away, and there are some stars, like some fairly large red giants, where we can actually synthesize the shape using a technique called interferometry. And interferometry is good, and it works, but not on all stars. And we can't see these bright stars that are not very large as disks ever. So we will never, so far, be able to see the stars as the disk shape they are. And to point that out, and I don't know if I've told you this before, I say it in my lectures, and I'll be talking about it in September out at Devil's Tower National Monument. I have to do a talk out there at a conference. The Devil's Tower UFO Rendezvous from September.
Where is that?
It's at Devil's Tower, Wyoming.
Wyoming.
Yeah, that's in northeastern Wyoming, and it's from 2000. I'm sorry. It's from September 14th through the 16th, and I'm actually speaking on all 3 days. I'm actually doing training. I'm training people on how to do image processing of things, just like we're seeing here. On the 14th, on the 15th, I'm doing a talk on exoplanets, And then on the 16th, I'm going to do a talk on UFOTOG, which is our UFO detection system. I just noticed Jimmy Church came online here. I don't think he's in chat, but he came online, and I had asked him a question today, so I was just seeing if he wrote me. I apologize for stuttering there a bit. Anyway, so when I go out, I'm gonna do those talks, and when we look at the skies here, and you compare them to, say, Devil's Tower is light free. And then in Arizona has passed laws, just as Connecticut, believe it or not, that says if you're going to put in street lights, they have to be fixtures that point down and do not allow stray light to go up. Like right now, when I look out of my dome, okay, it used to be, when I look out of my dome, I could see street lights illuminating trees in the distance, okay? I look out now and I just see a dark silhouette of the trees. I do not see light hitting the trees anymore. I used to. But Connecticut law says that when the lights, fall out of service, or when the light bulbs blow, you can't replace them with a new bulb. You have to change the fixture to a full cutoff fixture. And that has actually helped the Connecticut skies, for instance, get darker over the last several years. And it's going to get darker still, And so I think that's kind of cool. And it's a really exceptional program. And I kind of a little bit all over the place there. I mean, we talked about the Ring Nebula here, and then we talked about Devil's Tower. But I believe that when we see things like this, it inspires us to want to just, get the best. And we talked about that little tiny star in the center. And the sky has to be nice and clear. You don't have to have you can't have a lot of light pollution to be able to see that tiny little star in the middle. And here it is. It's beautiful. And we can see all the details. And I actually upped the size of the cartridge in our card on this camera to 64 gig from 32. Can you tell I really like doing what I'm doing? Let's see now. That's 25 seconds at 1600. I'm going to go one more, and I'm going to go down to, believe it or not, 800. And let's see what we get. Same thing, 25 seconds.
A comment I see come up a lot in these chats is everyone just loves how excited you get when you take a picture and some of them come in before we can see it, and just the anticipation that basically what you're going to see, and the excitement is just infectious. So
I'm glad.
Yeah, we can tell how much you love it, and we love that you are taking us along for this journey. So
I'm glad, because I really do. I appreciate everybody for coming along and joining me on these crazy mixed up nights.
And I also think it's a great law that they have the light shining down, because even if you're not an astronomer or someone that does this as a hobby, I remember I don't know when it was, 2000 or something. A lot of Canada and some of the U.S. had a blackout for 2 days.
Really?
And it was the first time I remember, everyone just piling out of their houses and walking around, and you could actually see the stars, and it's people were falling over. They're like, wow. It was like that cartoon when, they're all the kids are walking out and rubbing their eyes from the daylight that they haven't seen in forever, and that gets people inspired, just being somewhere where you can appreciate the stars. And that tiny faint little dot in the Ring Nebula, I cannot believe that we have telescopes that we can see these things. It's remarkable.
Well, that particular star is not the hardest thing to see. There are harder things to see, but still, it is pretty amazing, isn't it? It is.
You're talking millions of light years away.
Well, not
how do you even wrap your mind around that? And look, here's the picture. It's crazy.
Yeah, I know. Well, the Ring Nebula, as I said, it's only 1,400 light years away. And in parsecs, if you remember the parsec we talked about, 3.26 light years per parsec. It was another distance measure we used. It's 420 parsecs. So, the Ring Nebula being that far away is is really still, it's pretty amazing that we can actually see these tiny little things that are a tiny little thing in the sky. But the Ring Nebula is a pretty bright one, after all. Now, I have been purposely waiting until it's come up a little higher because I've been unsuccessful so far. But on a night like tonight, where there's significant transparency and significant seeing, we might get the veil, which is that supernova remnant. And before we do that, I'm going to take us to the N star in Cygnus, one of my favorite double stars. This is Albireo.
Okay. John wanted to know if you had ever talked about the moon, or sorry, the exomoon Kepler 1625b.
No, I don't believe that I did.
Do you know what he's referring to?
He's talking about 1625, Kepler 1625?
Yes.
And he's talking about, did he say B or D?
Beta? B, like Bravo.
Okay. Yeah, no, I haven't talked about that. That would be a planet. And I haven't talked about that.
But do you know anything about it, or like is that something you will talk about in the future, or have talked about in the past, or just not on this channel?
I don't believe I actually talked about it yet. I mean, give me the designation again.
It was 1625b.
1625. Okay.
1625 Bravo.
Okay.
And he said he called it an exomoon, but they're saying it's an exoplanet, which is your preference of study, and a moon discovered outside our solar system, says John.
You're saying, but he said Kepler 1625?
Yes.
Okay.
It says, has Mark talked about the exomoon Kepler 1625 Bravo? Well, he said B, but I'm saying Bravo. A moon discovered outside our solar system.
Yeah, no, I have not.
John, is this a new discovery, or? Okay, you asked if it was Bravo or Delta. What's D?
Well, I'm not. I mean, there's a 1635 Bravo. And that's a Kepler 1635 Bravo. But I didn't see 1625. And the reason that's significant about 1635 Bravo is that particular planet, there's only one known in this particular star system. It's a lot larger than the Earth, but it's dead center in the habitable zone of the star. So it's in the perfect location to have water on the surface, water in the atmosphere. And if it has land mass, it will actually have, potentially, could have life as well. But I don't know. I haven't looked at 1625 Bravo at this point. And I will, if you want. I can do that at some point. I promise.
Oh well, no. I mean, yeah. I mean, definitely it's something to look into for future streams. Or just.
Sure. Wow. Now this, just so you know, as I was saying. This is my favorite double star of all time. This is Albireo. And Albireo is the N star in Cygnus. And when you look at this, you actually see this beautiful blue star, and you see this gorgeous orange star. And Albireo is a double star. It's a beautiful double. And I think we actually calculated. It's a 34.7 arc-second separation, and we actually calculated the distance between them, which is just about 4,600 AUs, astronomical units. And it's 430 light years away. And so they're just stunning, this pair. And when we look at this, we're looking at, a pair of stars that are stable. And there's the larger one is a K3 giant. Okay, so that means it's either a luminosity class 2 or 3. And so that K3 giant is the one on the lower right. And we have another star that is next to it, which is, of course, that blue one. And it's a B8. Okay, so Baker 8, B8 class. So that's a hotter star in its main sequence, and it's got a temperature of over 12,000 Kelvin on its surface, and it's 190 times as luminous as our sun, that blue one. And that's amazing. So can you imagine being around stars like this if there were planets that were rotating or orbiting both stars? Absolutely amazing. It would be crazy just to think about that. That other thing about that B8 star, that blue one, is that it's a very, very rapid rotator, meaning it rotates once on its axis. All right, the sun takes what, 28 days? This rotates once on its axis in just over half a day. That means it's moving extremely fast at the equator. So, as a rapid rotator, it means it may very well have a sort of a oval shape. It might have a flattened elliptical shape because of this. So this is just an amazing system. The two stars are just amazing for their quality and capabilities and beauty. And I'm just very, very impressed with these guys. So my favorite double star system in the whole sky, right here, Albireo in Cygnus, the Swan. Now, shall we go to 51 Cygni, which is a area right, or 52 Cygni, sorry, which is right next to the Veil Nebula, the supernova remnant. Here we go. And let's see.
Now, I gotta ask, do you and some of your astronomy friends or scientist friends sit around and say, okay, now what if there was a habitable planet like Earth orbiting Albireo, and just come up with different theories of how life might evolve and what creatures might look like and how things would work and everything?
Yeah, well, we're crazy that way, yeah. Sure.
Yeah, because you have the science and you could actually work it out and say, is this feasible? What are the chances? I would love to be a fly on the wall at a conversation like that.
Well, you better watch it, because you may end up being included in a conversation like that at some point. And then what are you going to do?
Well, I can come up with all sorts of crazy theories, but then it's that logically makes no sense and could ever possibly happen. So, it's not like you can really follow through with my theories.
Oh, nonsense.
One day maybe.
Maybe one day. All right, this is...
Well, people that didn't understand what they were seeing were the first astronomers, the first philosophers, right? So you don't know. You don't know who's going to find the next answer.
All right. This is the Veil Nebula, by the way. This is the supernova remnant in Cygnus. This is just one part of it. It's massive. So this is a ISO 40,000 photo at 13 seconds. And to date, I haven't had the transparency or the seeing to capture this well. I could capture it slightly, but I could never capture it too well. And now, oh my god, wow.
Oh,
I'm sorry. I apologize.
We love it. We love it.
Oh my god.
These are the highlights of the streams for us in chat.
I believe that.
We squeal with delight.
Okay, when you look at this, you're going to see the filamentary structure of the veil above 52 Cygni. Never seen this before at this location. It's been impossible to check. Look at that. Holy cow. Wow. And
okay. Timestamp this, because this is going up on the Facebook site.
Well, actually, I just moved it down a little bit, and we're gonna actually get a longer exposure. I'm gonna tone down to 25,600 and go up to 25 seconds. So it'll be a little bit brighter, and there'll be a little more detail. This is almost overhead. We have good seeing, good transparency, and you'll see that filamentary structure of the supernova remnant. You got to remember that these larger stars, they don't die in a peaceful way. When they go, they explode, And it happens because the nuclear furnace basically shuts off instantly. And then the only thing left, the only force left, oh my God. Wow. The only force left is gravity. And it collapses the star on itself. And when that oh my God, this is just amazing. When that happens, we actually see the star, collapsing on itself within seconds, and then the star can literally explode, because all that stuff is coming down really, really fast, and it bounces, hits the core, and it just bangs off that core. And when it bangs off that core, unfortunately, there's no place for it to go, because the core is made of iron, usually. And iron cannot be converted into anything else in that state, in normal processes, normal fusion processes. So it doesn't get to convert. So it has to convert using a process that's really catastrophic. That process, of course, is actually this process we're talking about, and that is the supernova process. When that rebound occurs, the pressures are so immense that the star blows itself off. It blows off everything, and it ends up scattering to the cosmos. And so we're seeing the Veil Nebula, okay, after wow. We're seeing it after it's been after a significant amount of material has been sloughed off of this thing. Really, really pretty. Just gorgeous. So I can actually knock out the light and make that a little better. Oh man.
Yeah, Daryl wanted to know if a nebular or O3 filter would help pull out the veil.
Absolutely. I don't have any filters to use right now. I don't want to. I have filters here, but I don't want to take the time to figure out. You gotta understand, this is prime focus photography, so I can't actually get something like that and make it really fast change and so forth. Okay, I know it's bright, but look. You see that detail? I just went to a really high. Look at that right there. That, you can see next to that star, you can actually see that very sharp-edged part of the remnant. That is just spectacular. Wow. Holy cow. That's a beautiful image. And this is, again, keep my volume settings off. You don't want to hear me screaming. So that's actually a beautiful image. God, as bright as it is, it's pretty, because there's you can do something with this. I look at these things as raw images, and you look at them and say, "Oh, that's just kind of bright and crappy." I see a little bit different. I see it a little bit differently. So, okay, I'm gonna just try 13 seconds at 25,600. It won't be as bright. And there might be the happy medium. See, what you do is you hunt on either side of overexposed, underexposed, and workable. And let's see if 13 seconds at 25,600 is workable. And it is. Wow. Now you can see the color. All right. Now, when we come in, check this out. Wow. You can see the purples. You can see the reds on the border of this filamentary nebula. It's just stunning. Phew. I just, no words. I mean, this is absolutely stunning. Really, really pretty. Oh man, this, I gotta tell you, man, this is, Keith's gonna want one of these. I'm gonna have to, you know what, after we, I'm gonna keep this one. This is one we're gonna do over and over. So, all right, I'm gonna do 13 seconds at 25,600 again. Thank you for bearing with me, guys. I know that it's difficult. Is it 12:04 right now? What's the time right now?
Yeah, 12:05. Well, 6.
Okay.
Oh, I think you're 3 minutes behind me, but whatever.
Oh,
a little after a minute.
Okay. So I'm taking another one. I'm going to take about 8 of these, guys, so just bear with me. It's better than you know, freezing my butt off and then saying, oh, I got to do these, I got to do these. I don't want to have to do these. And then eventually, I'll be able to transfer these to the machine. I'm just kidding. Sorry, I can't get enough of these. They're beautiful.
It looks so delicate.
It's very delicate, but it was born of explosive cataclysm, and that's what's so beautiful about it, believe it or not. That's what's so beautiful about this. Ah, man. God, it just looks like it's so wispy, yet...
Yes, I was thinking that, like a thin little ribbon of...
like a cirrus cloud in the sky, you know?
And you say it's mainly made of iron?
No, it's made of many different materials, many different elements are in that. And what's cool is, when we look at the veil, I know it keeps flipping, because I'm taking pictures and pictures and pictures, that's why you're seeing me do this. So 13 seconds, I am going to process this and make it a processed photo up on the companion site.
Yeah, just getting there.
I don't even know if I'm going to get any sleep tonight. I'm going to probably be doing this. Wow. So I was saying, and I was leading up to this, when a large star does explode like this, and it explodes outward into space, it also is creating new elements. And so we see new elements in our periodic table. I'm sorry, not new elements, but elements from our periodic table are created in stars like this. And anything above iron, which is number 26 in our periodic table, is created in the heart of a star, or an emerging neutron star for some of the more elaborate elements. And if you think about that, you know, how in the world, I mean, stars are little fusion furnaces. They create all kinds of elements normally. But if you think about it, you know, it's hydrogen, it's helium, lithium, beryllium, carbon, nitrogen, oxygen, right? Fluorine, neon, and then, you know, magnesium. I'm sorry. What comes there? Magnesium. I memorized the periodic table song, and I can't remember because I'm on the spot. But all the way to iron.
Because you're not singing it.
Because I'm not singing it. That's right. I have to sing it. If I sing it, I'll probably get it right. You know, and that'd be kind of crazy of me to actually try to do that, wouldn't it?
Not at all.
Oh, look at that. That's just so pretty. Let's see. Let me see if I can do this. Let me see here. Okay. There's hydrogen and helium and lithium, beryllium, boron, carbon everywhere, and nitrogen all through the air, and oxygen so you can breathe, and fluorine for your pretty teeth, neon for the pretty signs, and sodium for salty times, magnesium, aluminum and silicon, phosphorus and sulfur, chlorine and argon, potassium and calcium and scandium, titanium, vanadium and chromium, magnesium. And let's see, this is the periodic table, noble gases table. Let's see, something in alkali react explosively. Shoot, I don't know. But then it starts with then iron after that. So it's iron. Iron is the one where normal processing in stars stops. All right, that's where it stops. And unfortunately, we don't have the best understanding of how it works, but we do have a pretty good understanding of how the elements are created in the hearts of the stars and in merging neutron stars. In fact, we didn't know until recently that some of the higher periodic table elements were actually created by merging neutron stars. This was something in the last couple of years. Sorry, I just lose my breath every time I see this. God, it's beautiful. I can't stop taking pictures of it, but I will because I'm driving you crazy. I'm sorry. I'm really sorry. I don't mean to be doing that. But it is.
We love it. People are commenting every time you do it. So.
Like, is this guy ever gonna stop this baloney? I mean that.
It's infectious. when you get that excited, I mean.
Well, you're
I don't think astronomers can do this job without having that kind of passion.
I'm sure that's true. All right, I'm actually moving to another area of the Veil. We were just on the western part of the Veil. Now we're going to the eastern Veil, which is just a little bit farther away. It might be a little bit fainter, but it's a bigger, broader area. And let's see if we can see anything there. And we're going to be doing, again, 13 seconds at 25,600. With the seeing and transparency as it is tonight, I don't think I'll see nothing. I think I'm going to see something. Oh, man. I just, I'm sitting here shivering, and I just, oh, my gosh, look at, oh, yeah. Okay, I'm going to move.
Don't those little bursts of adrenaline warm you up, though?
Yeah, I'm all warm. Now I'm going to go back to this. Okay, let's just do one more of these. Whew, I am amazed. I am astonished. I am very, very pleased. This is really, really, really nice. And look at this. Look at this. Look at this. Oh. Guys, look at this. You're seeing blues and reds that are really there. These are colors that are really there. This is the Veil Nebula, the supernova remnant in Cygnus. This is a remnant of that explosion that is actually, 2,600 light years from here. And it's literally 60 by 30 arc minutes in size. So do the math. Do the math at how far apart that has come out to be. Jesus. This is the Eastern Veil remnant. It's just stunning. What was that? Oh, man. Absolutely stunning.
I don't know what's going on over here on this channel, but I hear a bunch of grunting and moaning, and I figured I'd come to see what's going on.
Well, you're here just in time, ladies and gentlemen, and everybody out there. This is Keith from P&K Space Imaging, and he's come to join us. You guys closed down for the night because the moon is set, right?
We are not closed down for night. Actually, I am simulcasting you right now on P&K.
Wonderful.
Pointing everybody in your direction.
Look at this. This is the Veil
so hopefully
Nebula.
they come over and subscribe. And you're getting some magnificent images.
Is that that's
from
the
what
Veil?
I've seen?
I said to you, I don't know if you heard it, but I said, Keith's going to want a picture of this.
Yeah, you know what? I'm sitting here with a friend of mine. I'm like, yeah, he knows. I'm going to want that.
Amanda, you brought him in?
Yes.
Yeah.
Now you're fired.
Tricky.
It's in the mail, right?
That's awesome. No, I'm glad. This is good.
Yeah, I told her to add me. I was like, well, don't tell Mark. I said, just add me.
Well, I heard that blink, and I was like, wait a minute, that's a Skype thing. And I saw.
Yeah.
I was looking for like an error. I thought, oh, would I lose my stream? Is that something from OBS? Look at this. This is.
There's nothing I can do about that.
Look at it. This is the Eastern Veil remnant. You can actually see the convolution in the structure of that thing. Look at that. All that little tiny wisps and everything. I mean, you're literally looking at one star's result from having exploded. That's one explosion that caused all of the stuff you see now. The veil is incredible because it's actually a big circular pattern. Now it looks circular to us, but of course that's a sphere. We don't really see stuff that might be coming toward us or going away from us because it's very thin cross sections. But where it's like in the edges, where it's going around the circle, like circling the grapefruit, I told you with the Ring Nebula, that's exactly what you'd see, and it's beautiful. And the reason you keep seeing it show up and then go away is because I'm taking repeated pictures of it, because I want to actually stack them, stack them, them, and come up with a final image. So I'm just gonna do a couple more of these. God, it's just, it took my breath away. And I was saying before, Keith, we have that. It's really good transparency, really good seeing tonight. So I've been waiting for the Andromeda Galaxy to get a little bit higher. And
well, I'm glad you're viewing good tonight because man, we had it all awesome out of Miami earlier.
Yeah.
And it just went downhill like quick.
Oh, that's just terrible.
Like half the last like hour and a half, we've just been staring like black screen off and on, But yeah, I mean, I've been having you and Bill up just kind of checking in on you guys, see what's
great.
going on. So
thanks for joining us. I'm so glad you could join us tonight. I thought this was pretty good. So now I've taken enough of the Eastern Veil, and what I'm going to do now is I'm just going to do a 20-second exposure at the same 25,600 ISO, just to see if I can sneak out a little bit more detail. And for those of you that watched this before, you saw that it got a little bright, but you still had enough detail in there. So I kind of backed it off a little, and it ended up showing us just about as much. And we didn't lose too much nebular detail in this. So let's see what this does. This will be might be a little bit too bright. Oh, yeah, it's a little too bright, but still, I mean that. Oh man, and it's hard to believe that's actually moving very quickly through space. But as far as we go for our lifetime, it's gonna just look like it's sitting still, and it is not. But because of the transparency being so good tonight, you know what else I want to see now that the moon is down? And I got enough for the veil. I think we're going to go now to one other little spot. And that is, not one other, but one of many. I think I'd like to check out down in Sagittarius. I'd like to go down there and check out the eagle. And I know there's somebody in chat that'd like to see the eagle. And I'm moving there now. Here we go. Ta-boom.
Going for the eagle.
We're heading to the eagle. Oh yeah.
I know Daryl likes the eagle.
Yeah, he does. That's what I was talking about. I'm sure he wants to see the eagle.
So you're doing just a big potpourri tonight. Is that what you're calling it?
I am. It's the astronomical potpourri.
Nice.
Yep. And that's exactly what we're doing. It's just a potpourri, and it's a. Hang on one second. I'm actually.
Well, here's the thing. I'm looking at this image on screen, and I have so many questions, but I'm not going to dog you with them right now.
Ask me questions if you want.
Do it.
Yeah, I know. I was thinking about it, but I'm not going to hijack your stream. So.
Well, you're here, so hijack.
I know, but I'm kind of just sitting back and listening. I'm going to chime in when you mess up.
You've done so many good things for me. Why would I want to shut you down if you want to ask something of me, for crying out loud? So what do you want to know?
Let me get my question together. I'm gonna have it on mute because I do have people actually here with me. So I'm gonna have it on mute so you don't hear us talking. That way it doesn't disturb what you're doing. And then I'm gonna jump back in with some questions for you. All right.
I got people there. That's awesome, man.
Sweet.
I got no one here, and it's freezing. But it's just. But I'm not feeling it with all this, going on. Okay, let me see here.
But seriously,
on in PK's chat.
Yeah, seriously, but beautiful, absolutely gorgeous images being taken
it's really
tonight.
Stunning tonight, man. I'm so excited by this. So this is 20 seconds at 25,600. It's just a stab in the dark at the eagle. I want to see if it's a good starting point. And I promise I won't do 500 exposures of this thing. Yeah, that's too long.
Keith, a few people are saying they're hearing an echo on your end.
Oh, Keith is echoing. Echo.
I don't hear it. Yeah. Well, I don't hear it, but...
Hold on, let me, I'm just going to right now real quick just so I can hear myself, and blah, 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 blah. Now I'm going to check the stream. I'll be right back.
That's funny. Yes, I do it within 20 seconds. And speaking of 20 seconds, I'm doing a 13 second at 10,000 ISO shot. And I need to move down. I knew this before and I didn't do it. All right, let's do this. Yes?
Not sure how long Keith is streaming for, but I'll do my best to try to grab questions from over there too if you want.
If you'd like to, that'd be great. I would appreciate that, Amanda. You're indispensable on the SkyTour LiveStream. Wow. Oh, man. Just gotta zoom in on this now just to see what I'm looking at. Wow, there they are, the pillars of creation. Wow. Yeah, you can see folks, you can see right in the center, you can see that dark little pillar If you turn your head a little bit to the right, cock it over to the right a bit, you can actually, it looks like it's going up and down to your vision. It goes from the lower left to the upper right, through the center of the screen, below a bright star that's in the center. That's the central pillar. Then above that bright star is another pillar, and just above that bright star is at that edge of that dark pillar is the bright area of nebula behind it that this dark material is blocking. All right, and the lighter material behind it is also putting that dark lane below the star in silhouette, which is why we're seeing that. And then of course we have that little tiny, very delicate, small structure just below it again. It's just an amazing location. Oh man, this is 13 seconds at 10,000. I actually think I can go down to 6400 and increase my exposure to say 20. So 20 seconds at 6400 ISO sensitivity, and now it'll be the same photo because it's a one-to-one relationship, remember, but it'll be less noisy, and it won't have a lot of that electronic grain noise in there at all. It'll be less than we saw before. It kind of goes up sort of in a strange way. Oh man. Phew. I am unable to tell you how much this is so very different from how we've seen this in the past. Another thing I want to tell you is, in the winter skies, we get this. This is something we get in the winter sky quite a bit. All right, we will get good seeing and good transparency in the winter skies quite a lot, and summer skies it's rare, which is why we have this. You'll also notice on screen that there's a little square with a slash through it. That means my battery is dying, so I am going to shut the camera off for a moment. And don't worry, I've got extra batteries in the house, but we won't need them.
You know what? I listened back to the stream, and actually on my end, me and Amanda are both echoing.
Oh,
so I don't know.
Well, maybe I should echo. Maybe. No, batting. That's crazy. We already took.
So you know, after they said that Keith was echoing, they said I was a bit earlier, but then I thought it had cleared. And I know sometimes if one person doesn't talk for a while, you'll get an echo for like the first sentence or two, but then it clears. And I don't hear anything from you, Keith. No echo, no.
Yeah, you're clear to me, Amanda, and Mark's clear. It's just for some reason going out on the stream.
Wow. Well, I'm actually I have been using my my wireless headset here to talk to folks.
Oh, major improvement too.
It is. It's like, you know, it's like I can talk like this now, and I can stick my head on the dome and talk, and it's like, oh, I look outside and I just like my leg get jelly because it's like beautiful out there. I'm gonna take us to the Trifid Nebula, the Trifid Nebula. Here we go. It's right nearby. Yeah, we should see it showing up here. Oh, there we are, down there. A little bit on the right. Yeah, there it is. And we'll just move over to catch it just a little bit. As soon as the telescope beeps, it's locked in, and now we can move. Okay. And now
at the pillars of creation, what we were just looking at, what was the cluster on the bottom right?
It was part of the. It was actually part of the. Part of that whole Eagle Nebula complex. And you got to keep in mind, you know, there are certain types of stars that will illuminate these clusters. Typically, they're hot O stars with a high ultraviolet output that will cause the hydrogen gas to basically absorb energy. The atomic, the atoms will absorb energy. Oh wow! And when they do, they will actually. What am I looking at here? Hold on. They absorb energy, and when they absorb energy, they actually, they will actually become very. Sorry, I'm trying to. My mind is being bombarded with splendor here, and it's crazy. Um, I see the problem. No, so as I was saying, or trying to say, I thought I was trying to say, what I'm looking at here, this is not the Trifid Nebula. This is actually Messier 21. It's an open cluster down in Sagittarius, kind of looking toward the sort of in the vicinity of the center of our galaxy. It's a little south, but that's the open cluster we're looking at right there. It's a beautiful little jewel box. It looks circular. It has a circular pattern to it, and it's just really, really pretty. I really like this whole area of the sky, and I can't get enough of the summer sometimes. You know, the summertime actually has some of the best skies, and as we saw tonight, some of the best seeing in transparency. So you take a look at those stars, you actually see how the stars are they're very varied, and you see the different colors actually. Some of them are bluer, some look white, and you know, there's a red star a little bit up to the upper right, which is actually a binary star. There's two of them there. It looks elongated because of that, but it's just so beautiful, and I'm very, very happy that we could see this. Now I'm going to move on to the Trifid itself. We want to go to the Trifid, and I think it's very important to see the Trifid. It's right near this. Man, that's just amazing.
Keith, did you formulate your question yet?
No, not yet. I'm kind of just sitting back and listening, learning a thing or two.
Oh, there's nothing you can learn from me. You know all this stuff.
That's why I feel bad when you always say, oh, if there's any questions in chat. I think everybody is just stunned at everything you show us and all the information you give us. I mean, what can we ask that is going to be better than the information you're already giving us, right?
Well,
so
I mean, I'm spewing mental diarrhea here, so I'm not leaving any room for questions, I'm sure. You know, but that's okay. It's better to be, you know, fully informative, entertaining than not. So, all right, this is going to be 15 seconds at 6400. Picture's being taken now. The black screen always means I'm in the middle of a picture, not in a dark room. So, now what we're looking at is the Trifid Nebula, the Trifid. And with the seeing tonight, it's going to be, I think, fairly beautiful. Oh my God! I've never seen this like this. Oh my God, folks, I am so sorry. This is just stunning.
How could you have never seen this like this before?
I've never had an observatory with this kind of an instrument before, with this kind of a camera, with this kind of a computer, with this kind of a setup, with this kind of alignment.
Wow.
To put it simply.
Oh, I like this one.
Look at that. Those three lobes of the Trifid are beautiful. I mean, those are sharp and clear. And with the beautiful seeing tonight, we don't have any problem with trying to get you know, trying to get it out of there. So I can see this very nicely.
I recognized the name, but I forgot what exactly it was going to look like until it came up on the screen. This is a really, really pretty one. I really like this one, yeah.
So this is 25 seconds at 3200. I've gone down on the ISO sensitivity because that means the noise level will go down as well. I don't think I'm going to bed tonight. I think I'm going to just get heavier clothes on.
I was going to say you may still want to run into the bedroom and grab a blanket or something.
I know. I'm oh wow. I had to do another one of those. I'm sorry.
Invest in the Snuggie.
Yeah.
Get them to sponsor you. Snuggies for the hardcore astronomer. Brilliant. There you go. There's your commercial.
Hey, if you can come up with the approach,
get in on that.
Can do it.
Oh well, I mean, can you imagine Paul and Snuggie on his roof with a telescope? There's your ad right there. We got the whole campaign sorted.
Snuggies for the amateur astronomer and all of you. And it's also for the professionals. See a like old man with a big Snuggie around. It works for me. That'd be funny.
Well, you see all Neil deGrasse Tyson's vests. Yeah. It's like the Starry Night, or he'll have the solar system. there's the print for the Snuggie.
Oh my god, that'd be funny. And then he has one on there, and he looks at the camera and he goes, "Oh, yeah," and that's all he has to say. But a big Snuggie around himself with a solar system on it. That'd be funny. Really, really good.
It rates itself, really.
It does.
Aren't you glad you joined us, Keith?
He left.
Oh, he left. Yeah.
Yeah. Okay.
I'm still here. I was ending the stream over on PNK.
That's fine.
Oh.
Yeah. I'm still here. I'm still listening. I'm just
that.
doing stuff in the background. That's all.
Even when you're not here, your comedic timing is brilliant.
I am here in spirit.
All right. Shall we go down to the Lagoon Nebula, Measure 8? You ready to see that one? Good, because I am too. Oh yeah. Oh yeah. Kool-Aid's here. Okay. That might be centered well. Let me just do a nice photo of that one. Now, this is fairly low to the horizon too, so the fact that it looks as good, these look as good as they do. This is 25 seconds at 3200 again. Let's see what we get. I'm just astounded by the veil. Oh man. Whoever in the chat reminded me to show the veil. Thank you. You made my night. And if I had t-shirts, you'd get one. I will. I'll eventually have t-shirts. Why? Because I want one. Oh, okay.
I cannot remember who originally requested the veil. I'm sorry. I must have said it instead of wrote it down.
Oh, it's okay. Let me actually try, if I turn on the video here, let's do the video, and let's increase the exposure, see what we get. Wow. Okay, this is live Lagoon Nebula, live Measure 8 at 4K video. I'm recording it in 4K. It only is going to come out at 1080p. Sorry. To YouTube. YouTube won't let me put up 4K yet. I don't know why. Keith will know. But look at that. That's the lagoon in. It's actually at ISO of 102,400. This is at 128,000. This is 160,000. As you can see, it's rapidly getting too bright, but that's pretty as well. But see, the nice thing about using this mode is you can actually see everything you're looking at before you even take a picture. You see, like here, this is like the photo. This is the screen before taking a photo. This is what you see, and with your eye, you actually see it kind of like, well, you see it sort of this way. I'll show you. You see it this way, kind of with your eye, but not perfectly. But let me just take, this is 25 seconds at 3200 one more time. Sorry, no, it's not. It's 25 seconds at 51,200. This is going to be too bright. Remember what I said, you go back and forth, you try to find that bracket, find that location where you get the perfect shot. Then you take a bunch of them, and when you stack them, that dim nebula becomes very, very bright. And there's products out there to stack imagery for you if you ever want to try it. See, I told you it's too bright. It wakes you right up. Then that imagery is that stacking imagery. Sorry, stacking software is called Deep Sky Stacker or Registax. 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 Sorry about the brightness there. It's like, oh, nuclear explosion. I'm sorry. One more time, 25 seconds at 6400. Meanwhile, I will look for other things to view.
Would there ever be a good reason to take a picture that overexposed? Would that help?
I don't think so.
Show something?
I don't think so. But it would benefit us to take a picture it would benefit us to take a picture overexposed if we were able to actually see see something like very faint within the cloud, and I'm not sure we could.
Like, would you use that to look for black holes or something, or?
No. Yeah, you know why? Because black holes you wouldn't really see. You unfortunately wouldn't see them. So it's a little bit bright, all right? But, you know, when we look at this, okay, all right, we can work with that. We can do some things, but you see that's actually a little bit of blur there because I actually probably bumped the telescope a little bit. But now, because of the seeing, I want to go look at something that's a little bit higher up, and that something is going to be a favorite for some of you that you know of. You know of this, and it's called the Omega Nebula. Here it comes. Now the Omega.
Hey Mark, how long are you going for tonight?
I don't know.
Okay.
I don't know.
Until his fingers freeze and he can't operate the camera anymore.
Yeah,
is it cold up there?
Well, the temperature's dropped, and you know, I'm not going to be stopped by cold. I'm going to be stopped by dew on the telescope. And right now,
yeah, everybody gets stopped by the dew.
Well, I have a hairdryer in here, so I'll just run a hairdryer and dry it off, and that's good for another 15 minutes, you know. But still, that's not any fun.
Well, yeah, I was just wondering. I'm gonna get something to eat real quick. So I didn't know if you were planning on wrapping anytime soon. If not, I'll be right back.
Okay. No, I'm not going to wrap up like within the next 10, 15, that's for sure.
Okay.
Eat fast, but don't choke.
Yeah. Yummy.
Oh my. Okay. I just did 10 seconds at 6400 of the Omega Nebula, and it came out gorgeous. So what I'm going to do is 20 seconds at 6400 of the Omega Nebula, and I'm going to move the telescope a bit and bring the Omega up a little bit. Okay, that might be too much, but we'll see. I just want, oh my God, this is a beautiful night. You know, it's a beautiful night like this, you forget everything, and you don't get cold. You get cold, but you don't think about the cold. Oh, and yet, unfortunately, I can't.
People in chat don't appreciate that. Like, you know, we're only, well, I would assume a lot of us are nice and somewhere comfortable and warm and everything, but guys like you and Paul from P&K Space Imaging are out there in the elements bringing this to us for free. So, I mean, thank you again so much.
That's okay. I mean, wow. This is the Omega Nebula now, and check that out. Is that not beautiful? That is just stunning. And I'm just very happy with that. And that's 20 seconds at 6400. Now with our one-to-one thing, I could actually, you know, go down to say 4000, and then go up to 4000, you know, ISO, and go up to 30 seconds, and get the same type of view, which I'm doing. I'm going to do it. And I probably won't. I won't keep doing all these on you like this. I'm very happy to just record little pieces of this and look at this and say, wow, this is stunning. Wow, that's stunning. Absolutely stunning. It's a beautiful, beautiful night. Yeah. Beautiful night. I hope you guys don't mind the music in the background. I like it. It helps set the mood, and oh, jeez. Stuff like this, it makes it all worth it. Okay, a little bit of alignment issue there, so I'm gonna go up to.
A little skeptical with the music, but you know what? I think it's good. It gives you a chance to sit back and enjoy what you're doing too. So
that's correct. Because sometimes I'd rather let the music speak. And it gives the opinion for me, you know, like if I used to say like, wow, and you hear this, I mean, it speaks for me. I don't have to say anything, right?
Yeah.
I don't have to say a word.
It gives people a chance to fully absorb it too. I mean,
yeah. That's interesting. In the Omega Nebula, I just noticed over here, right there, look at that star. It's actually a little bit orange. And I'm going to kick us here for 1 second and zoom in, do a critical focus, and see if I can do a little better than what we've got. So 1 second here. I think we can do a little better here on the focus. I'm going to go out and then back. And back. Alright, I think we got that now. And let's just try a 15-second again. I didn't go over too far. Okay, 15 seconds at 8,000 ISO. So it's like 15 seconds at 8,000 ISO. My. Yeah. Jeez. Yeah, I'm just a little bit crazy tonight. What can I say? I'm just reveling in this absolutely beautiful sky. When I looked at the veil before, I couldn't believe what I was seeing. And now I'm looking at the Omega Nebula and seeing so much more than we typically see. And I don't see a darn cloud in the sky.
I was just about to say, some people might not know. Mark did have plans to stream the last few nights, and it was all day clear to clouds at the sky, clouds at the night at the very last minute,
Yep.
within
Right at the very
an hour or
last
so before stream time.
Right at the very last second, we got clouds. How dare you, you evil one.
So I'm glad that you're getting repaid in a way, getting nice clear shots and beautiful images, and never
Really?
before
Really pretty.
seen shots. Yeah, awesome.
Really, really pretty. Yeah, and I'm just amazed at how beautiful it is. Okay, so let's see now.
And it's another reason to hit the bell beside the subscription button, because it depends on whether when he streams, he can't say for sure, I'll do it tomorrow or I'll do it next Friday, or, so hit the bell beside the subscribe button, and whenever he goes live, you will be notified.
Yeah, I appreciate that. Okay, we're going off the Omega now, and we're going to an open cluster that we've seen before, but is just really, really pretty, because on a night like tonight, where being higher in the sky makes a difference. If we just go to our 4K video mode for a moment, and then increase the ISO, you can see it there on the right. That is the special cluster just in the Sagittarius Milky Way, and it's called the Wild Duck Cluster M11. And it's not a globular cluster. And people are surprised by that, but this is not a globular. This is just a star cluster that is just on its own. It's a very beautiful star cluster. So let's do let me just bring down the ISO. 12,800 at 8 seconds. I just want to showcase some of the stars behind the Wild Duck and part of the Wild Duck cluster, part of the Milky Way. Oh man, holy cow! So I just gotta leave that there so you can see that like that. Look at that absolutely amazing cluster of stars. The Wild Duck is not a globular, like I said, but it is, it is something that is 6,100 light years away, and it's just amazing. And I mentioned this before. It's about a third the size of the full moon. So 3 of those side by side make the full moon. So that's pretty big in the sky for for something that's, again, 6,100 light years away. Sorry, I had to cough there. They think it has around 2,900 stars, and 500 of them are brighter than what we call magnitude 14, and the rest are obviously faint. But look at that. That is just a beautiful, absolutely stunning cluster. And we can zoom right in and go for a little interstellar trip there. And the focus is pretty good too. And you can see some different colors. Again, not being a globular, it's not made of the oldest stars in the universe or in the galaxy. It's actually made of stars that are have some reasonable metal contents, that is, not hydrogen and helium, but beyond. So it's really cool. And we have this blazing Milky Way overhead right now. And it's almost like it's just so stunning. Okay, let me, listen to me. I'm almost like forgetting what I'm doing because it's so pretty. There's so much to do. I can't get to it all. All right, let me see now.
Okay.
All right. Anybody have any requests in chat, by the way?
You know what?
What?
Okay, this is bad. My chat froze. My chat froze, and I missed a lot of. I don't know how chat froze because I'm seeing all the images live. Oh, guys, I'm sorry if I missed a million requests. Okay.
That's okay.
See how far back.
I'm gonna go to another thing right now. It's called it's up in the Cygnus Milky Way. It's called the Little Dumbbell. And now if we do a 4K vid quickly and check out whether we can see it. Yeah, I think it's there. Okay, so I just got to get out of this and reduce the exposure, or reduce the ISO 12,800. We'll do 8 seconds at 12,800 and see if we see it. That's odd. I actually don't see it. Okay, that's pretty strange. I would expect to see it. But maybe I can... Alright, you know what though? I'll align on this.
Okay.
I was really just waiting to see this, so you know, I'm looking at. We weren't looking at the dumbbell. It was something called the little dumbbell, but this is actually. Let me do a 4K vid. Give you an idea of what we're looking at here.
For questions or requests. Desiree was saying, are we supposed to be seeing things moving? Do things move, or Earth starts traveling? Because some of this is live video, and then some of them are pictures that we're zooming in and defocusing.
Yes. We're not supposed to see... We typically don't see anything moving. See, I'm stuck in the dome now because there's a skunk right outside the dome. so I can't go. I can't leave.
Oh. Can you take a picture?
No, I can't because then
Don't move the telescope. Oh my god, if you scare him, it's over.
Yeah.
Make sure he doesn't do a stampy dance. That's the warning sign.
Yeah, I don't want to see a stampy dance. No. And to the folks in chat, I'll tell you a little story. And we are looking at the Andromeda Galaxy, by the way.
Okay, that was requested a few times.
I know, and I figured I'd make good. But I am looking in the direction that the wind is coming from, so we might get some dew. So I have to kind of be careful. I was working on a project here in the shop where I was creating a submarine model for the Navy. And as I was sanding the submarine model, at the end of my garage, I could see that something had walked in. And it was a skunk. And this little skunky was like, you know, full grown. And the skunk was looking at me, and I was looking at him, and I was going, oh boy, what am I going to do now? And as I looked at him, I just suddenly got this overwhelming urge to just let him in. And I didn't... Oh, did you just see that? A satellite just flew through the field. You'll see it in a couple seconds, guys.
Okay, hold on.
Actually, as I say it, they'll see it now. I mean, they've already seen it. But yeah, it was pretty cool. It flew right in front of the Andromeda Galaxy. And I was moving the telescope at the same time, so it looked like it moved in an erratic pattern, but it was me moving the telescope that caused that. Alright, I'm going to go down to ASA 10,000. Yeah, 13.
Wait, finish your skunk story.
Yeah, I'm
you
getting
invited him in and...
Sorry. I invited him in by just, like, not kicking him out. And he walked right up to my foot, started sniffing my shoe, and I was very careful. I just kept sanding. I said, all right, I'm going to get sprayed by a skunk. I'm going to get sprayed by a skunk. What can I say? And I just started sanding and looking and just doing it, and he sat back on his haunches and he's watching me. So then what I did was I did something I never thought I would do. And you got to understand, my mother was a Native American, and so I always had this connection to animals, and so I figured that this is really kind of a test in a sense of whether I really am connected. And so I ended up squatting down, and with one eye closed, the eye on his side so I wouldn't get sprayed in the eye, I started petting his back, you know, scratching, you know, in his back, just behind his head. And this little guy rolled on his side and wanted me to scratch his belly. And I started scratching his belly, and he, oh God, this is beautiful. And when I scratched his belly, he was just so passive. And after that, I couldn't do any wrong. I walked around the shop. He'd follow me like a little dog, sit down with me. He never, they can't jump so much, so they didn't like come up on my lap or anything, and I never picked him up. But I squatted down quite a bit, and I kept petting him. And when someone saw that this skunk was in my shop, they called the animal control. And the guy came roaring up the driveway with this truck and with his little, he had this special snare, and he had gloves on and a hood and a faceplate mask. And I'm at the end of my garage, and little Skunky comes, and they call him Skunky. Skunky came up and just sat on his haunches next to me, literally contacting my left foot. You know, and he was sniffing my foot and looking around. And they don't have very good distance vision, so, you know, I was basically there to protect the little guy. And the guy gets out of the truck, puts the hood on, and then his little faceplate, and he goes, "Don't move. He's right next to you." And I looked down, and I said, "Yeah, you're not going to believe this." And I squatted down, and I began kind of roughhousing with him, you know, a little bit. And the Skunky loved it. He was just roughhousing back with me, rolling over and doing things like a dog would do when he's excited. And so the guy took the hood off and the faceplate, and he goes, "I have never seen anything like that in my whole life." And I said, "No, this is my skunk. We made friends." And he goes, "Well, you know, I hope you're not going to stink too bad after that." And I go, "No, he hasn't been releasing at me at all. He's very, very passive with me. He's very fine. He knows I'm no threat." And he goes, "But," I said, "if you come over with that noose, I guarantee you're going to go back smelly." And the guy says, "Yeah, I don't think I'm going to come over with the noose." I said, "Good idea." So he ended up just leaving. But it was really kind of fun to play with my little Skunky. And then he disappeared for like several months actually. And I came home real late one night, and I came up my driveway, and my outside light goes on because my car came up. And there, sitting as if waiting for me, was little Skunky, sitting under the light. And I got out of my car and I went, "Oh, Skunky, it's so nice to see you. Look at you. You look great. I thought something had happened to you." But he was all weird. He was running around, kind of doing circles. And he literally ran in between my legs, running around, making like little, not figure eights, but just circles around my feet. Excited. He wanted me to see something, I think. And I looked up and I saw 6 more pairs of eyes in the driveway reflecting in the light. I was like, one big pair of eyes, okay, and 5 little pairs of eyes. Skunky had children, and I was like, "They look just like you. I'm so proud of you, Skunky. Look at you. Look at your family." And the mother skunk was absolutely livid. She was like, making these noises and circling the babies and like panicked that the human was gonna like take them or something. But Skunky knew better. And I said, "Oh, that is so nice of you. I'm so glad you came to show me your family." And then I said, "But you know what? Why don't you go back to them? You're making her crazy." And he certainly didn't understand me, but maybe it was just like the right moment or whatever. And he went back to her, and they went across behind the car, right across my lawn, and down into the thicket next to my house, where to this day I still smell them, like tonight. One of the offspring, or one of the offspring's grandchildren, was tooling around my yard, and he's out there. It's beautiful. It's just beautiful. Wow, the Andromeda Galaxy is pretty. Andromeda Galaxy has low surface brightness, guys, so it's, you have to take really long, deep exposures of it at low ISOs, and you need a night that has seeing and stuff like this, but it has to be a night that's really, this is an Arizona object, I can tell you that.
Well, I'll have to take your word for it, because I have tears in my eyes now. I love that story.
Oh. Well, well, the other thing was I was changing the spark plugs. Again, the relationship with animals goes way back. I was changing spark plugs in my pickup truck in my driveway. I had a piece of wood laying across the hood, and I was up on top, and I was really struggling to get these things out, and so I started pulling them out, and all of a sudden I felt this weird little tiny, like somebody taking 2 fingers and poking into my back, and then coming forward a little, poking some more, poking some more, poking some more. And it was like they were traveling up my back. And I turned around thinking it was someone like one of my kids or whatever. And I turned my head to the side, and cocking its head, looking straight at me, literally an inch from my nose, was a blue jay sitting on my shoulder. It had hopped up my back and was looking at me. And of course, I just gave an immediate name and said, "Jay, what's happening?" I said, "How are you?" And he's just like, he seemed genuinely curious. So I ended up, and I'm looking for something. Don't worry, guys. I'm actually trying to find something here for you. Here we go. And he said nothing. Okay, moving now. And then he sat on my shoulder for quite a while, and I then very slowly came off the truck, and he did not move. He stayed right there, and I was just astonished with this beautiful bird just sitting on my shoulder. And what I discovered was that this little creature was actually I don't know, very enamored with me. And the next thing you know, it was like every time I would go outside, I'd see him fly from a distance, and he'd come toward me, and he would find me, and he'd just land on my shoulder whenever I went outside. Little blue jay, you know. And I just was really taken back by that, because I thought it was really nice, very nice. And so that was the blue jay, and I call him JJ. And sadly, he either passed away or he's gone after time, or migrated away or whatever. I don't think they.
Yeah. Why can't migrate away be the first possibility?
Oh, I don't know, because they do have a lifespan.
Yeah.
They do.
Well, I was getting nervous in that skunk story when Buddy from the SPCA or whatever showed up.
Yeah, well,
I was devastated.
Nah, not to worry, because they never got him. Skunky and his family, the progeny still live in the thicket. In fact, I just went through that thicket 2 days ago, cleaning weeds out and stuff, because it's actually a big ravine full of very, very big rocks that they put in to help mitigate water issues here. And I could see remnants of Skunky's work down there, the nibbling and so forth of some of the branches and shoots. So it's really good.
How long ago was that? That was the skunk that was outside your dome a few minutes ago. Do you think that's like a great-great-grandchild or something?
At least a grandson.
Oh, that recently.
Yeah, no, it wasn't too long ago. Yeah, and then I looked at, this is the double cluster, by the way, we're looking at right here. Incidentally, just so you know, this is a SkyTour LiveStream after all.
Are there any skunk constellations?
No, not that I know of. Maybe in another culture there might be a skunk constellation. The double cluster is in Perseus, which is all the way down on the northern horizon. It's fairly low. But it's really pretty, it looks gorgeous, and I'm just really pleased that this has worked out so well. I'm going to try and just move over a little bit to the north a little more. And I want to try and locate another little object here that may not be visible because it's so low, but we'll try. What's going on there? Okay, let's see here. This is 5 seconds at 409,000. It's really, really gonna be bright.
Just said you went offline. Check
yeah.
Out back.
That's funny.
Oh, okay, you're seeing that too? Okay.
Yeah, I was just seeing this weird reaction on the screen. Okay, bright white coming. Sorry, folks, that was a mistake. Gotta bring it back to delete it. And it's gone. Alright.
Oh, they already stopped. Never mind.
Alright, so now I just don't know what to say. This has just been so pretty tonight. When it talks about tonight's best, you betcha it is. It's really beautiful. Really, really pretty. Alright, I'm looking through. The next supernova remnant will actually come up at 227. So about an hour and a half, but I'm going to be off by then, I'm thinking. Because I'm kind of freezing here. Not to worry. Oh man, let's see.
And you can't even put any kind of heater in there because of the telescope, right? You can only resort to blankets.
Yeah, you can't. Yeah, it has to be blankets.
But doesn't all the the telescope itself generate some heat over time? Just from running?
Very little. It's actually very little. The telescope will generate very little heat. Yeah, don't mind me right now, folks. I'm just trying to locate a couple things in my list here. You know, another little thing that something I did, which I haven't mentioned before, I don't think, is that I ended up, you know, learning how to play an instrument called the didgeridoo. It's actually, you know, I played the drums, I played the electric guitar, but that's, you know, I've done for a long time. But didgeridoo turned out to be very challenging. And what is a didgeridoo? It's a hollow bark, you know, that's been, it's a hollow tree log, basically, that's been basically hollowed out by termites. So what's the point? Well, the point is that Aborigines played the didgeridoo, and the didgeridoo was actually very instrumental, no pun intended, in wow, did you see that? No, you won't. Not yet.
Not yet.
You'll see it. Alright, hold on. I'm trying to look here again.
Oh, I saw something go by the right-hand corner.
Yes, it did.
Is that what?
Yeah, that was it. And then I don't know what it was, but that's something that was interesting. Okay. Now, okay. Now this is Uranus. Okay, and I'm going to, let's just actually leave it like this and just try a straightforward magnification. Now it looks like a star, okay, but you can actually see that Uranus actually has there's a little hint of a blue in there. Can you see it? And that's
not me, not yet, but
yeah. Well, you know, I'm talking to the people who are seeing it as I am. Wow. By the way, when we were taking pictures of the veil before, it was still not quite high. And so I'm going to take some more photos of it momentarily when we get to it. So you can see a little bit of the color now, can't you? In this, and it's really pretty.
It's very pretty.
Yeah. I mean, it's just a little
Ronald
dot.
Wanted to know what the temperature at your location was.
Right now the temperature feels like around 54, 55, but you know, it's that's warm, relatively speaking, but there's a little gentle breeze that's entering the dome slightly, and it's coming through the opening, and it just chills you right to the bone, you know. That's okay. I'm still hanging in there. I'm still awake.
And we appreciate it.
Well, I'm trying to appreciate it myself. But this has been just a beautiful night, guys, I have to say. Beautiful night. And I would like to wonder if I can see this. Tell me it's not. Oh, it's... Where are you? Okay. I'm going to try and look at this even though it's a little low. So obviously I'm moving. Alright. And notice I don't always tell you what they are until, you know, we get it closer, because I don't want to disappoint you. on, stop. Oh, okay. Alright, hey, it was a star. Alright, let's see what we got here.
And can you tell Maddie again what kind of telescope you have, please? What you're using?
Yeah, this is LX200 GPS 10-inch telescope. So it's really pretty. It gives good views. Okay. And now I think all we have to do is move over a little bit to the right and we'll be good. Okay. Now let's try, on this beautiful night of good transparency, let's try 5 seconds at 25,600 to see if we can see the Whirlpool Galaxy. We can, but it's just a little too bright. So I gotta cut that back. I'm gonna come down to, oh, my mistake, I was at 256,000, sorry. 12,800 at 5 seconds. I misread it. It was 256,000 ISO, not 25,600. Oh man. So let's see now. Yeah, we got a interesting. That's just interesting how that looks, because typically we should see it far better than that, but it's actually, believe it or not, we're actually capturing this through some trees. So that takes it right out of the running. We could have looked at it earlier in the night. My mistake. But you know what we can see?
What?
We can see the Spindle Galaxy. And I want to check that out. We're going to check that out. See, it's a potpourri tonight, folks. Astro potpourri. I hope you don't mind. I hope you like it. Let me see now if I can get that. Alright, let's go up to the Spindle Galaxy.
Do you have any suggestions on what a good starter telescope would be?
Plenty. I would say you might want to go to Orion telescopes, and they send all over the place. Who would this be for?
For Tidy Minion.
Tidy Minion. Tidy Minion. Banana! That kind of minion?
I don't know. A few people actually came over from P&K Space Imaging. I think Tidy may be one of them.
Okay. Yeah, this is the Spindle
Anyway,
Galaxy.
regardless how you found us.
Yeah, thanks for coming on over.
You did land on a wonderful night.
Yes, this is a beautiful night. Now let's 13 seconds at 5,000 ASA or ISO sensitivity on the Spindle Galaxy. And let's check out what we can see. You might notice there's a little red cast on the imagery. There's two reasons why that happens. For one, it could be because the sky has a light pollution from sodium vapor lamps. And the telescope is, the camera is very sensitive to that. For another, it could just be there's some dew on the lens and we're getting this backscattered light in the air. But the air is fairly vapor free, and but usually the backscattered light could put the orange glow from the dome back into the telescope. And that's a possibility. But I'm going to right now actually do a dew check, because it's low enough where I actually have the telescope is actually low enough where I can actually put the light on and just see what's going on here. So yeah, that's just terrible. Dew is a horrible thing. And Well, we don't have any. Yay! Okay, we're good so far. So it's got to be some kind of a backscatter issue. So this is the spindle galaxy. This is an interesting object because the spindle, all right, is a galaxy that's actually kind of on edge to us. You can see its edge, and it has a dark lane that you can see that splits it top to bottom, and that's actually a circular lane. It goes around the whole galaxy. It's a dust lane. Many galaxies have these dust lanes, and this is no different. And the spindle is 47 million light years away. So we're seeing this galaxy as it was just after the Jurassic Age, and I think that's kind of cool, you know. And so when we watch and look at these astronomical wonders, we have to think in terms of they're actually, we're seeing them as they were so long ago that it's actually just, it boggles your mind to think that the universe is that large that you could see that. 25 seconds at an ISO of 2500. So we're going to reduce the noise and get about the same kind of a view. By the way, there's no mosquitoes tonight, just so you know. I think it's kind of cold and they don't want to be out. And that makes me happy. I'm just happy. Alright, let's see what we got now. If we go in and zoom in on this little tiny wonder. Yeah,
I know our good friend Daryl's going to bed, but he was saying earlier he had star maps from the 50s,
yeah,
and star maps from the 2000s, and even in that short of a time, there were differences. And I think he was saying where he moved, he could see the Milky Way when he first moved there, but now he can't. So, I'm not sure if maybe I read that part wrong or not, but...
Daryl's, is he in Colorado?
He's where FX Models is.
Okay, so he's where the FX Models...
Colorado Springs, yeah.
He's where our Planetary Replica Division is. Yeah. FX Models Planetary Replica Division is a proud sponsor of the SkyTour LiveStream. And yes, it's I realize it's my company, but it's not. You know, the point is, I like to try and, you know, sponsor good stuff, and I think this is good stuff. I do. By the way, the Spindle Galaxy is Messier 102, just so you know. Now, let's see what else we've got before I freeze to death here.
And the link to FX Models is now in chat, so go check out.
Oh, thank you.
Some of our other side projects.
Yeah, we do planetary models for new building construction all over the United States. We actually have museum displays in Istanbul, Turkey, and we have somewhere else overseas. Can't remember where, but we did a job in Istanbul for this museum there, for a natural science museum, which was great. It was wonderful, and that was a very good project for us. We enjoyed it a lot. And then let's see, we did planets for this other organization. It's actually, I've been doing this for quite a while, about 3 years now, and we were in hiatus for a while, and now they've actually started us back up very soon, and that's going to put us into doing many more of these planets, which is fine. I love them. Okay, we're going to go to the Zenith, by the way.
You've used some models for demonstrations on, like, NASA's unexplained files and what on Earth, haven't you?
I have. I mean, I've done some interesting stuff with these models, you know. Because, I mean, once you know the planets, and it's like, if you're someone who is kind of considered a go-to person for these, you know, then they come to you, and it's really nice. It's wonderful. Okay, this is back on the veil, so I'm gonna I'm going to try and do 25 seconds at 2500. You know, I'm taking you with me on my crazy little forays tonight. And you have to understand, guys. You have to understand. There was no way I expected it to be clear tonight. I had high cirrus clouds. I had rumbly, you know, rain clouds all day until late in the afternoon when it was just this ugly cirrus clouds, which typically don't go away. And typically don't go away. And oh my God, you guys, I gotta say this. You know, earlier in the night we took pictures of this Veil Nebula. This is 52 Cygni down here, that bright star. This is the eastern. Is it eastern? And the Veil has been on my list to view for a long time. And looking at it, I'm just astonished at how beautiful it is. And it really is. It's knockout drop dead gorgeous. I just can't say it enough. You know, and this is the Western Veil where we're looking at right now, and this is just so incredible. Oh, you know, you can see the colors. You can see how there's actually intricate little filamentary structure in there. And this is at 2500 ASA. This is, you know, ISO. So I'm going to go to 3200 at 25 seconds. Do one more. Oh man. And this is almost straight up. So we're seeing through the least amount of what we call air mass. And it's logical. It is what it sounds like. You know, the least amount of air mass. So we're actually seeing a very relatively clear sky object here. Then I want to go to the Eastern Veil after this. Hey, look at that! You see the? Tell me if you see the purple in this. I mean, it is just, without a doubt, it's got to be the most beautiful thing. You know, you actually see the purple in it. I mean, it's beautiful. Absolutely beautiful. I can't say enough. You know, and the Veil is, again, low surface brightness, meaning it's just not very bright. And I get it. You know, I understand that. I'm going to try a 5000 ISO shot at 25 seconds. Now that the moon is set, we have absolutely no excuse. This is just beautiful. Just beautiful.
Ronald had a question. Now, I think I know the answer, but it's good to think about for the future.
Sure.
He wanted to know if you... Hold on, because it was like... Okay, first he said, do you record your observations for later review? And I figured yes, because the video is going to be uploaded when the stream's over.
That's correct.
But then they said, no, what I meant was, do you use the info for teaching or consulting? Is that something you will be doing after? Because if you go to his companion page on Facebook, he will put up some of these pictures, describe what we're looking at and stuff, but, you know, for the future, maybe are you going to, like, maybe edit some of these videos and bring them to different conferences you do? Show them?
As a matter of fact, I actually do that. The Devil's Tower UFO Rendezvous I won't be doing this with, but I actually will do it for some of the other things. For instance, thanks to you, as it's August 12th, right? This is coming down. I got to teach that class in Japan, basically.
I'll have to double check, 12th or 14th, but...
Okay. But, yeah, I was doing at 11 in the morning, 12, actually 12. I got to do a meeting in Indiana, and then from oh wow, and that's not that good actually. I'm not seeing what I wanted to see there. Then from 8 o'clock in the evening onward to, I don't know exactly when, I have to do a talk in Japan via satellite, obviously. So it's gonna be kind of cool. And that was your thing, right? You got me that one.
Yeah, well, I mean, it was just kind of for fun. I happened to see it posted and thought it might be something fun for you to do. I don't know if anyone listens to Richard C. Hoagland show, The Other Side of Midnight. There's a teacher from Japan that calls in once in a while, Michelle, and I saw she posted if anyone has an interesting job that they'd like to be kind of interviewed. It's kind of because she teaches English in Japan, so I think it's going to be kind of like guess your profession. So the students will be able. That's how I'm interpreting it. You might know more detail, but
that's funny.
Kind of to learn, like if you spoke Japanese and you were stuck in America or Canada or something, what words would you ask to get the information you needed, kind of thing, right? So I think it's gonna be really interesting. I'm like, how would you like an astronomer? And she said that would be really cool. And I said, hey Mark, how would you like to do the show? And he said, that sounds like fun. And I said, okay, Michelle, Mark, Michelle.
That's right.
So
that was very cool. And
I think it'll be really interesting and get young Japanese students interested in astronomy and show them what's possible from their own backyard.
I agree.
You wait 20 years, see what happens, right?
Yeah.
I think they're pretty young students. I don't remember the age, but
yeah, you don't know what people are, what they're gonna think, what they're gonna do in 20 years. But it's fun to actually, consider that you're giving them something to think about, and that you might change their career path.
You never know who's listening or what what one little piece of information might spark someone's imagination. So
that's exactly right. That's exactly right, and that's kind of why I got into astronomy. I'll tell you a little story about how I got into astronomy. I don't know if anyone knows out there, but when I was a kid, I had open heart surgery at age 9, and when I got out of the hospital, I was the only kid in my school, actually the only kid in town that had this surgery. In fact, I was the 17th person in the United States to have this surgery, and they had to repair a valve that was bad, or else I certainly wouldn't have survived. So, in repairing the valve, after they repaired the valve, and I was home, I had to relax. Now, they didn't have a lot of information about what you do, and wow, this is beautiful. I'm sorry. That's just stunning. They didn't have a lot of information about, recovery times and things like that, because I was the 17th person to have the surgery. It wasn't like this was something that, they did every day. So, while I was home, I just decided that I was going to just make up a space station plan, because isn't that what every little kid does? Every kid, fresh out of the hospital from heart surgery, wants to write up a space station plan and send it to NASA, don't they? I mean, I'm sure you're all saying, well, yeah, of course, all kids do that. So I wrote up a space station plan, and I did it on torn out pieces of notebook paper from a notebook. And then I sent it down to NASA. And when I sent it to NASA, a NASA scientist looked at, actually read, and marked up my plan and said, good idea, you might want to consider this for these CO2 scrubbers that you're talking about. I was 9, and I learned about CO2 being bad in space, and I knew you had to get rid of it. So I called them CO2 scrubbers. Things to remove CO2 from the air. I know it's not due to me, and I probably heard it, but they're called CO2 scrubbers today when they talk about them in space travel. In terms of that, they call them CO2 scrubbers, that to remove CO2 from the air. So I'm not claiming credit for it. I'm just saying that it's probably due to the fact that I actually saw it somewhere else as a kid. Anyway, the scientist sent it to me. He said, "Oh, that's very good, very good. You know, well done." And he sent me back my plan with his marked up commentary, and then something that I called my space box. It was a box that was bigger than me at that age. It was long and it was big and square, and it was full, not partially filled, full to the top, with books, mission patches, and all kinds of amazing space paraphernalia, and models. The guy put in models in there for me to build, and I was like, wow, you know. And I thought, this scientist is a great guy. I want to be an astronomer. I want to get into science and space travel someday. And he's the guy that got me into space and science. And his name, you may know this, some of you, I don't know how many people are in chat 'cause I can't see YouTube right now. But I said to this guy, I sent him an email 2 years ago for the first time since age 9. And his name is Gentry Lee. Gentry Lee is the man who put the rovers on Mars. He got New Horizons out to Pluto. He's the guy who's in charge of all robotic exploration of the solar system for JPL. And now, that's what he's doing now. And when I actually wrote him an email a couple years back, and I said, "Gentry, I don't know if you remember me." And I made a little like, haha, I'm sure you don't. But yeah, I wrote you a space plan. When I was a little kid, I made a space station plan, sent it to you. And, you know, because of your response to me, so with all the encouragement, and you gave me a space box full of stuff. You know, you must have put every brochure NASA ever made into that box, and all the cloth mission patches from the Gemini and the Mercury program, and the Apollo program. You know, you gave them all to me. I thought that was fantastic, and because of you, I'm into astronomy today, and I got my degree in astronomy. I said, I think that was just an amazing thing, and I just want you to know that I'm deeply grateful. I said, I know it's you know, 40-something years too late, but, you know, I just want you to know now that I'm very grateful. And he wrote me back literally it had to be within an hour. And he says, "Oh, that's such an incredible story. Of course I don't remember, but," he goes, "that is something that I know I did. I did that with a lot of people." He says, I just loved it. That was great stuff." And he thanked me for writing and said, "Let's keep in touch. This will be great." So, you know, we've obviously been keeping in touch. But a really good guy, and you know, very down to earth, and that's the thing you learn about these, you know, scientists. You know, people like that. They're very down to earth people, you know, and that, I think, if you think that I'm, you know, down to earth, well, it's because, like I said, you know, I've stood on the shoulders of giants. You know, it hasn't been me, but it's the influence of other people that drove me and made me who I am. So, you know, how can I be haughty and arrogant when there's so many people out there that are just amazing? You know, just great people, you know. Well, anyway, this is a 6400 ISO shot, 25 seconds long, in the region of the North American Nebula, which is like the veil, almost directly overhead, a little off center. So we'll see what this is like. We should see lots of stars. And this battery is running down, so this is probably gonna be the last image before I have to go back in and get batteries and do stuff, and I'll probably want to warm up for a while, so I may have to sign off here, guys. Yeah, I do. Oh, there's just something I gotta do. I just gotta do this. All right, hold on. I'm not ready yet.
Okay, well, RJP wants to know,
yeah,
are the scrubbers the same as HHO generators?
H2O generators? What do you say?
I don't know. HHO.
I don't think so. I don't know what the HHO is. What's it? Because
I don't.
I mean water generators. H2O is water.
I'll just,
I assume he's meaning water, right?
I don't know.
Okay. I think he's saying water, because it's H2O, obviously. But well, that said, I think either way, okay. I'm familiar with this stuff. I think it's an awesome. It's awesome to be into space, space travel and all sorts of things like that. I'm amazed, in fact, at how people have been able to explore space and do the things that they've done with the amount of lack of knowledge we have of our universe. We actually know so little about our universe, so very little. Yet we are very much so, very much into gathering knowledge. Knowledge is power. So we want to be able to get information. We want to be able to seek out. I'm not going to say seek out new worlds, explore. I'm not going to say that. No, but it's sort of like that, isn't it? I mean, we are trying to answer the questions about where we belong in this universe, and can we get to this place? And wow, that's kind of far. So let's figure out a way to get there. And I do believe that we will, when we consider the Alcubierre drive. Miguel Alcubierre designed in 94, and that's the kind of thing that is really, really critical. Getting ourselves to a point where we can actually. Sorry, something on the screen that was dumb. I didn't want that to come up, but it did. Getting ourselves to the point where we can actually do some serious exploration of the universe. I think that would just be really, really awesome. And that means, obviously, getting off this planet, off this rock, and getting ourselves out there. And so how would we do that? I mean, there's only one way to do it, and that's to bite the bullet and build a craft that can actually, ply the reaches of deep space. I think that would be the way to go. I just turned the camera off for a second because I'm about to put it on the piggyback, because I want to try and see if we can get some nice galactic Milky Way shots here. So just a minute, if you don't mind.
Yeah, stand by, yeah.
What's that?
No, because I saw it offline, and then it came back, but it was just buffering, so I didn't know if it was just at my end, but then it went offline again, so I just said stand by. So.
Oh, well, it shouldn't have been stand by because I didn't stop the stream. So.
Well, yeah, it looks like it's buffering for a few people now.
It is?
It showed as offline twice for me.
Okay.
But just for maybe a few seconds each.
All right.
But then it was buffering the entire time in between. Okay, I think we're good now.
Is it good now?
It's good on my end. We will see what chat says.
Okay.
Back.
Okie doke. Okie doke.
This is like glitch. Should be good.
What? Yes. Good. Yes. No. No. Yes. No.
I'm seeing the word echo, but I don't know. It may have been just from that glitch, so we'll see.
Oh. Okay.
Let's see. We are looking at a black screen, mind you.
You are.
The,
You are. Yeah. You are, because I haven't got this in yet. I'm installing it on the back of the telescope, or actually up on the top of the telescope, and I'm just I'm doing it in the dark, by the way, but I have to say, my backdrop is the beautiful Milky Way over my head, and I'm just like, wow. And I don't know how to say it. It's just like, this is like the most stunning backdrop you could have to try and put something on a telescope. This is beautiful. You know, in the cold.
Yeah, it's just with the glitches, I'm not sure what all was heard in chat. Okay, so
yeah, me either.
Batteries. Please. And I just about given up on typing tonight. So many
Yeah.
typos.
Well, don't give up on typing.
Oh no, just a lot of typos, but
Oh,
they'll
okay.
understand.
All right, let's see. Get this.
There should be sound, Mr. Spirit.
Are people having trouble with sound?
Well, I don't know. One person said that they were hearing echo on me.
Okay.
Maddie can hear it. Mr. Spirit said, I'm back, but no sound or picture. You're changing the battery, that's why it's a black screen.
Yeah.
And
Well, no, I'm not changing.
I
the
don't
battery.
know
I'm actually
why.
I'm mounting the camera, and while I'm mounting the camera, I've got it. I do have it. I have the camera off to preserve the battery. Okay. Okay.
I think only one person's having issues with sound. Everyone else is saying it's fine.
Okay.
Except an echo on me. I'm sorry, I don't know.
I don't hear an echo for me, but that's okay. All right. Let's see now. Now let's see what I gotta do. Did I put the? Oh, I did. I put the lens cap there. All right. Now I just have to move this up. All right, 1 second, folks. I am going to. I just want to move over to the Cygnus Milky Way here. I want to see what we can do on this beautiful night. There's got to be something we can do here. All right, that looks pretty good. Okay, now this will not be very clear at all. All right, and I've got to actually. Oh, it's not going to want to do that, is it? We're going to space travel. Okay, I got to zoom in so that I can focus. All right, and let's reduce this. Okay.
And I'm seeing stars.
You seeing stars? Was somebody hit you in the head? You're seeing stars. Okay, I'm going to do this. There we go. I want more of this. Okay, so now. Alright, that's that. And now I'm going to do this. Okay, and then focus. Alright, that's the focus. Now, let's do a wider angle shot here. Okay. This is going to be 25 seconds at 6400. Here we go. This is just to see if we can get a nice Milky Way image over our heads here. We might be able to. It's a very nice night. Let's see what we can get. Actually,
It's night. Maddie wants to know if it's clear tomorrow night, would you be streaming?
oh my god. Oh ho ho. Remember I told you about trying to capture the North American Nebula? Well, guess what, folks? Here it is. Look at that. Oh, this. How do I? How? Just okay. How? Can anyone answer me? How? That's just beautiful. Can you see the dark? You'll see the dark. A lot of dark. Oh, man, I'm speechless. I apologize. I mean,
Just as you said, look at that. It went offline and it's buffering again.
no.
Okay, I think we're back. Okay, tell everyone how incredible the
That's
what is it? North American Nebula?
Yeah,
Great American Nebula?
No, North American.
North American.
Yeah, and this is in the Cygnus Milky Way. Look at this. It's like, oh my gosh, this is like, I don't know how to say it. Now, if I go to 4K video here, and let's see if we can. Okay, you can see the nebula. It's right there, just to the left of center. That is just beautiful. You know, absolutely just beautiful. So now if I stop that, and it's just to the left of center, if I can just bring it, if I go up to here, this is now zoomed in, and wow. Now, what I'm going to do is just go a little bit to the left, and a little bit up. Alright. Okay. Yeah, like I said, I ain't getting any sleep tonight, I don't think. Whew. Now we're going to do this again. Oh, I'm sorry, I went 25,000, I'm sorry, 25 seconds at 80,000. I didn't mean that. So this is going to blow you away. I'm just going to shut the camera off. So don't worry about the bright screen. I apologize for that. I got the wrong thing going. And this is 6,400. 25 seconds. I'm going to try and go right to... I'm going to go to 30 seconds at 6,400. And away we go. And we're zoomed in all the way with the telephoto lens on the camera, so we are actually we're zoomed in as we can go. And that's with the telephoto, so it's a 300mm telephoto. And you gotta walk softly because the slightest vibration will kick it off. The cord's resting on the floor for the thing. Let's see if we get the North American. Wow, what a beautiful star. Look at the, just look at the stars. Look at the stars. And look at Deneb. That's the brightest star in Cygnus to the lower right. It's almost like just a beautiful picture. Man.
That's beautiful.
That's just stunning. Holy cow. I want to pull back a little bit though, because I actually want to capture an even wider angle. I just want to try it. I don't know if I'll succeed. That should be good right there. We're going to do it again. 30 seconds at 6,400. I've got my back to the open shutter here, and it's like freezing. It's just, but there's no wet even on the outside of the dome, so that's good. So that shows me that we don't have dew yet. Dew would really kill it. Wow, can you believe this? This has been a great night, folks. I don't know if you realize how good a night this was. I was telling folks before, if you've just been in here a while, okay, that's too long. But I was saying that this is actually one of the prettiest nights And I'm sorry about the blowout there. Let me, that was too bright. Alright, I gotta drop down the exposure, hold on. Let's say 15 seconds at 6400, so half of that. And let's see if we can even see it at 15 seconds. Because if we can, well, that's good news, because then I can actually take a couple of them at that and stack those and get a result.
Yeah, Tron wanted to know what happens if you do something like go 1K at 2 minutes.
Oh, well, 1K?
Yeah. Yeah, 1K
Well,
at 2 minutes.
I don't know. I've never done it. I don't know. I wish I could answer that for you. I don't know the answer. I don't recall doing it. Alright, this is going to be 25 seconds at 4,000. So this is going to be even brighter. This is kind of funny because I see Capella coming up in the winter constellation of Auriga. Ah, yes. I've definitely...
I don't recall those names before.
Oh no, we have not. Oh, whoa, whoa, what did I just see? Oh. Wow. Hey. Oh my gosh. Look at this, guys. You can see the dark lanes of the Milky Way. You can see the dark clouds of gas and dust in our Milky Way right there. This is just absolutely stunning. You see the North American Nebula plain as day, right in the center. I mean, isn't that incredible? That is just beautiful. Holy cow. I just can't get enough of this, man, let me tell you. Now do you see why being an astronomer is something that you just can't get enough of? You know?
It's gorgeous.
Yeah. Wow. I'll take another one of those.
It really does look like, I don't know, like a painting or just, I don't know. Like an imagination. It's hard to believe that, you know.
Yeah. It really is. By the way, we're gonna after doing a couple of these, we're gonna go back to the Andromeda Galaxy. Because with this telephoto now set on the back of the telescope like this, this is certainly the best way to capture the Andromeda Galaxy. Because the Andromeda Galaxy is 4 to 5 degrees in size in the sky. And that's just incredible. So, knowing that that's the case, and seeing now that the Andromeda Galaxy, I can actually see it with my eye now, I have a feeling that I'm in for one hell of a photograph. Pardon my English. It's going to be really pretty because the Andromeda Galaxy is, you know, really high in the sky. I can't stop looking at this picture. You know, it's like, look at this. It's like, wow. All the convolutions. Now, here's the thing. You see the reddish tints? Those are the hydrogen 2 regions. Those H2 as in II, the Roman numeral 2. The H2 regions are those regions where stars are being formed. And in these star-forming regions, okay, the hot young stars will excite the hydrogen gas, and then the hydrogen gas will spontaneously drop to a lower energy state after it's been excited by the ultraviolet, typically from the stars. And when it does drop like that, drops that energy state, it gives off this red light, characteristic red light, and that's why we call it doubly ionized hydrogen. So that's what we're seeing here, these H2 regions. It's a rich, fertile area in the galaxy. And frankly, I can't wait any longer. I've got to go to the Andromeda Galaxy. I might come back to this probably after I've quit the stream or something and just come back to do this, because I am just absolutely taken aback by how beautiful this night is. I am. It's just something else. It's just crazy. Crazy beautiful. Okay. Wow, if I could-
Now this is going to be a fun estimate, but Pratt wants to know how many stars are in this image.
Well, the fuzzy white that you see in there is not stray light from here. It's actually more stars. So it's actually kind of hard to kind of put a number on that. But I mean,
That's just one tiny little section. I mean,
this is one tiny little section, and there's more planets than stars, you know, out there. So that's a whole nother thing, you know.
I guess it must take just a certain kind of person to be an astronomer, because I don't know how I'll ever get my head around that. It's too big. I can't understand that.
It's definitely crazy. All right.
And our JP wanted to know what size screen you were actually looking at this on.
I'm just using a little 19-inch monitor, computer monitor. And I also have it, I mean, every time this thing comes up, you just see the screen comes up and you see this gigantic thing, which is better than seeing it in the little viewfinder of a camera or in the little tiny LCD screen on the back of the camera. I'm doing 25 seconds, by the way, at ISO 4000 of the Andromeda Galaxy. And I didn't see it there just now. Oh, wow. I think I didn't see it because it was everywhere in that view. Let me cut this down a little bit. Yeah, it's got a... Hang on. I gotta move over a little, I think. Alright. Now, I'm just going to do a live view of this to see what I'm looking at. Oh no, is that like that because my camera lens got crap on it or something? Where is it? Hang on. Alright, let's see.
Ooh, I think I just saw something streak by.
You might have.
57.
Let me just do.
I don't know, this timer, I don't know. I have crazy numbers all over the place, and I don't know if they're anywhere close, so we'll see after the stream.
Okay.
Mr. Spiritus wants to know, what is your maximum upload speed?
Maximum upload speed is here. I think my maximum upload speed is around. I'm trying to remember what it was actually. I don't remember. I'd have to go look. I don't remember. Let me just. I mean, I saw the Andromeda Galaxy here. I just want to capture it. Alright, so it's not there. Alright, try this. There it is. Okay, so here you see the Andromeda Galaxy floating out there in space. And if I can just get over to it a little more, then we will be in good shape. So I just have to grab it. So to get there, I'm going to move over now. Oh, I think I didn't see where that went. Well, let's just try another photo here just to see where we are. Perfect. Okay. So there we are. There's the Andromeda Galaxy. So now what I have to do is I just do this. And I will do another test shot. This is not even a full density shot. This is just to see where it is. Oh, there it is. Okay, so now let me do a 4K video. And we saw it there for a second, but that's... There we go. Now I can pull it in. There it is. Okay. So now we can come off the 4K video and do a... Let's do 10 seconds at 32,000. Here we go. 15% camera battery left. And what are we gonna get? Oh, Jesus, that's beautiful, but it's too much. Let's do... Oh, wait, that was too much. Okay, 10 seconds at 4,000 ISO on the Andromeda Galaxy. The Andromeda Galaxy is 2 million light years away. So we're seeing it 2 million years ago. That's beautiful. So there's a... We're going to start now. Look at this. Okay. Yeah. It's nice. That's looking very pretty. Now, interestingly, just so you know, there's two more companion galaxies to it. One right in the center of the picture there. Let me move it to the center. Okay. That's in the center there. The little faint smudge. And then down below, we have one right there. It looks like a star, but it's not. It's just... it's a little hard to see. But why don't we try to take another image. Now let's take a little... This is 4,000. Let's do 15 seconds at 4,000. It'll be a little brighter, but it should be okay. Shall we? We shall. Remember, I talked about getting our stride here, with getting the values right. So that's kind of getting there. That's the Andromeda Galaxy, guys. It looks beautiful, especially tonight. Beautiful. And I'm gonna try to go to 25 seconds at 4,000 now. Yes, I'm a glutton for punishment. By the way, my toes are really cold. I can't feel them anymore, but definitely worth it. Oh.
You're not going to say that when you can't come out and play because you're in bed with a cold.
Or getting my toes removed because they're frostbite or something, but it's not that cold. Okay, now we're getting there. Look at this. Oh, I gotta go with it. Did it say 13% or 3% battery?
It was 15 a second ago. How fast does it drain?
Look at that. And it's not that bad. Wow. This is beautiful. Really, really pretty. So I want to do this now. Is it? Hang on a sec. Alright. Maybe I can go to 5,000. Okay. 25 seconds at 5,000 ASA. Oh, by the way, remember you mentioned the Pleiades?
Mm-hmm.
It's up.
It is up. I believe Vicky was the one that wanted to see that. I'm not sure if she's still in chat, though.
Well, there must be, what, 2 people left or something? I can't see.
No, we still have 17.
Okay.
A few people have gone to bed. We actually have quite a few Brits listening, so it's what, 3, 4, 5, 6, 7. It's 10 after 7 a.m. Someone was in from, I forget now. Was it?
Wow.
I forget. It wasn't Norway. It was somewhere. It was an hour further even. So you have a very, very loyal crowd here, and we appreciate all the continued love and support, guys.
Well, hey, this is nice because people can come back and view this later. They can also join us anytime during the night. Keith said he was going to come back. He never came back.
He said he was eating, so
okay.
He may have fallen asleep. He may have made an extra meal.
That's okay.
We have a suggestion from chat, actually, from Jerry. Can you possibly clear the buffering and cache on the telescope? Maybe it's too full. Could that be causing maybe a streaming issue?
No, I mean, when they see the screen go black, just incidentally, and that may not be what Jerry's talking about at all, but when the screen goes black, it means I'm taking the picture again. And then, okay, so I'm actually taking a succession of pictures. So now I got the picture up, and it's sticking around. This is the Andromeda Galaxy, and I'll let you look at it for a while because, it is nice to actually just see it, but it's really pretty.
Yeah, I'm not sure if that's what he was referring to.
Maybe not, but it is just unbelievable.
But that is something good to point out, because I don't even think about it anymore. Like, I'm so used to it if the screen goes black for a second. I know it's because you're taking a picture, but it's a good point because a lot of people came in tonight from P&K Space Imaging, and I think people are just randomly finding astronomy live streams and stuff. So remember to subscribe and hit the bell. But yeah, and you'll hear him say, the details of the kind of image he's taking, and it'll go black for a few seconds, and that's why. And then we'll come back with the next picture.
And because I'm doing low ISO or low sensitivity shots right now, I'm going 25 seconds. But keep in mind that I am using a camera that delivers to you something that would have taken minutes per shot, just not too long ago. So this is really far nicer.
And it's free.
Yeah, I'm not charging for this.
And the host is approachable. If you have questions or requests on different images you might want us to try to see, get them in chat.
Yeah, that's true. I'm did it already come back? I missed it. It must have already come. Maybe not. Hang on, I'm gonna wait. I must have missed it. It must have come back already. Alright. It must have come back. Yeah, it did. Okay. So I got a few of those of the Andromeda Galaxy. Now I'm going to do the obligatory Pleiades. Which, by the way, is Measure 45. So, Measure 45.
There's a loading message not associated with what you were doing that keeps popping up.
What's that mean?
I thought he was looking at maybe the camera setting when you actually press the button to take the picture, but I don't know.
No, not that I know of. Maybe. Let's see. Okay, there's a Pleiades. Pleiades is sort of in the murk right now, but I said I'd watch and give you a shot at it, so here you go. It's coming up. Really down in the murky murk. Murkety murk. There we go. There we go. We got the Pleiades there. And it's probably just a little too murky to catch the nebulous detail with the Pleiades. But we can try. The Pleiades are B-type stars, and as B-type stars, they don't have the capability to have planets per se, because they're just too darn powerful. They have long, very strong stellar winds. Okay, this is a 13-second ISO 5000. Might be a little bright because it's sort of in the lower end of the sky. Yeah. It is a little bit bright, as I said. But let's zoom in a little, see if we're catching. I will end up getting, by the way, I am going to get some filters that will allow us to do some really cool filtering on things like the veil and on the Pleiades as well. Because the Pleiades could use a filter to help view that nebulous detail, and one of those filters that we need right now is something called a sky glow filter. So a sky glow filter will help. So I'm going to go 6400 at 8 seconds. So we're going to have sort of a mix. Alright, and here we go. The picture's being taken.
RJP wants to know, is Andromeda brighter than Jupiter?
No, it's not. If you were to combine it, condense it down, then it might be. Overall, I don't know what the overall brightness of Andromeda would be, but of course its brightness depends on its distance. At its current distance, if you were to compress Andromeda down into just one point source, it wouldn't rival Jupiter. It'd be I think it'd be a little bit fainter than Jupiter, but not by much. It'd be fairly bright. Most objects are like that. Most objects are like that. But I have to say, looking at the sky tonight, this was really an unexpected pleasure, and I'm really happy that you guys took the time to spend it here with me. This is great. But, I'm looking up now and thinking, oh, sorry, you're actually seeing the dome. I apologize. I will now spin it around.
I was just about to ask, what was it that was just on the screen?
That was the Pleiades.
That was Pleiades. And it was M45?
Yeah.
Woohoo! That was quite memory.
You're getting good. You're getting good. And we're zipping through the sky.
Yeah, Pleiades is really pretty.
It is.
Very sparkly, twinkly.
Yeah. Yeah, but it was low, so it's kind of, bad, crappy looking, It's okay. Let's see what we got now. Okay. Alright, so...
And what are the three pyramid stars?
Oh, those are Alalam, Alatak, and Mintaka. Those are the Orion's belt. When you say pyramid stars, I assume you're talking about the 3 stars in Orion that were likened to be the stars that were the model for the 3 pyramids, the main 3 pyramids in Giza. That's what I'm assuming. Am I right? I don't know.
Give us 30 seconds. Probably that's Well, I see. Yeah, it is Orion. That's it. Yeah.
Okay.
See, when they said 3 pyramid stars, I was thinking the pyramids, and then I was thinking, unless they meant the summer triangle.
Oh.
Possibly, I think, but I don't know. I was talking about that recently, and I can't even remember where, but something that wasn't there a window in one of the pyramids that lined up with a certain star. I don't know if it was the middle one in Orion's belt, and it was something about the Pharaoh's spirit.
I can't tell you. I don't know. I actually don't know.
See, that's the problem with me. You know all the facts and dates and numbers and everything, and I remember vague portions of stories and confuse them.
No, it's still fine. That's not a problem.
Yeah, it was the Orion belt.
Oh, it was, okay.
Can we see it, or?
I won't be able to stay up that late. Orion will rise. If it's rising tonight, it'll rise really late. It'll rise really late.
Is there a time when you can see it, where it would be, or not from your location?
I don't know. I really don't know. I'd have to look and see. Okay, now this is what I'm looking at here. This is Lyra, and it's stars. I want to take a nice shot of that just for fun. 8 seconds at 6400 ASA, just to see what we can see. Wow. You see? That's pretty cool. This is kind of neat, because you can see, that's what you see with the camera, and this is kind of what you see with your eye. You know? So once again, that's what you see with your eye. That's what you can see with the camera. And then with the camera, we can zoom in and see even more details down here, which is just beautiful. Absolutely beautiful. Wow. It is just a stunning evening.
Yeah, it seemed it was buffering a bit when you were taking the picture, but then as soon as the picture comes through, it clears.
Okay, fair enough. Okay, now I'm right at that little weird zone where I gotta have the camera just a little bit zoomed in. And I believe that the camera, because it's getting cold, the camera's sitting vertically now, looking straight up. Practically, well, not straight up, but it's looking up at Orion. I was say Orion. It was actually looking up at Cygnus. And when it does that, whoa! I just saw a beautiful meteor. It just flew over, guys. It had left a trail behind it and everything. It was bright yellow, and it left a big trail behind it. That's an ablation trail, you know. It's you know, burning away. And they actually come in after me, and it's one of the Persians, you know, because of course the Persians are a very important meteor shower right now. Very cool, very impressive.
You didn't catch it though?
No, not on the camera. On my eye, I saw it fly right over the telescope. This is 8 seconds at 6400 again for just the Cygnus Milky Way area, and I just, wow, it's just so beautiful. And for the heck of it, I'm just gonna go up to 15 seconds at 6400 and see what happens. I know what will happen. And you'll see too. See, that's a beautiful. It's a beautiful view again of the Milky Way and the North American Nebula. And I would like to do another thing here. It's like I'm just not thinking tonight. It's like I'm crazy here. I got all this wonderful stuff that I'm doing. I'm trying to figure out where I want to go next, what I want to see, and what I want to do is I want to take a 15-second shot of the central Cygnus Milky Way, which is actually the part that you can see the brightest with your eye. And it's going to have some knots and structure in it, especially tonight. What a beautiful night. Oh, look at that. And you can also see M39, that little cluster, just right and low, just to the right and a little bit low. If I'll show it to you here. So it's right there. That's it right there, that little thing. So right there. Very cool. So I'm liking that. And now let's do another photo. Now the cold air is coming right in. 15 seconds at 6400, and away we go. I gotta tell you, because it's so beautiful out, and because I know I'm really pushing it, and pushing my my luck, you almost wish for clouds so you have an excuse to shut down. Because it's really so absolutely stunning. Wow. I just can't get over this tonight. It's beautiful.
I know, I even feel bad asking, but Tron wants to know if the Sombrero Galaxy is observable.
Thank heavens, no. I mean, no. No. If
I
it
know,
was,
all
if
these
it was,
requests at the end of the night.
I would
You're
have
never
seen it.
gonna.
I would have looked at it if it was. Clearly, so this is me turning the dome. So you can see we're looking kind of straight up. But, you know what I want to do?
And just so you guys know, I did throw the link to the companion Facebook group in chat again. The Sombrero Galaxy is actually there. I do remember seeing that. So in press streams, some of the pictures Mark's taken, he has actually put there with little descriptions and they're raw images that you're putting up there, so people can actually pull them and do fun little things themselves and experiment. And
I have more to put up there than I have so far. But yeah,
I've been slacking too. I know.
No, it's okay.
Even some of the pictures, I'll put them up. I just.
It's quite all right. Quite all right. This is just something else, man. I tell you. And now let's see. And now for something completely different. Oh, you know what I'm gonna do? This will be kind of an interesting little forward. We're gonna go. We're gonna go to. We're gonna look at the wild duck cluster again, but from a piggyback view. From a piggyback view on the back of the telescope. We're gonna do it this way. And see what we're looking at. See how it looks. Because this is gonna certainly look a little different than before. Because you won't have seen it quite like this. All right. So now that we're looking at that, and we've got like some. You can see some trees and stuff in the way there. But maybe I can zoom in and to kind of negate those a little. Let's try that. And let's just do now we're going to do a recording, a 4K video recording just to catch this. Okay, And that's where I want to be, maybe. Alright, shut that off. And I'm freezing, and let's just do 4,000 to 15 seconds again. It's going to be a little bright. I'm really happy with the battery on this microphone. It's lasting a lot longer than I thought it would.
Oh, it was a major improvement.
Yeah. Wow, okay.
Yeah, it seems like YouTube buffers when you take pictures now.
Interesting.
And it's only been just the last little while. I'm trying to pay attention to when it hits, but...
Okay. You can see the complex nature of the Milky Way right there. It's really cool. And I'm going to go down to 3200 and increase it to 20 seconds. So 20 seconds at 3200 ISO. See, this kind of stream is perfect for you, Amanda, because you don't go to bed. You don't sleep ever.
Yeah, but I'm nice and warm and toasty too, so...
Oh, yeah, well, I'm certainly not that, but... I mean, I guess get warned from the total... There we go. That's kind of cool. So this is kind of how it looks to your eye right here. Okay, a little less than this. Isn't that beautiful, though? That's the Milky Way down towards Sagittarius. Cool. Oh. Well, my friends, I have to tell you, I think I'm at the point where I am pretty much colded out, and I apologize for that, but I am gonna probably call it quits for now. I do want to
go with saving your toast tonight.
Yeah, you know, and you know, this is, you know, we've come to the end of another SkyTour live stream here at John Zach Memorial Observatory in Connecticut. Don't forget to tell your friends and subscribe. Hit that like button. Pass it on. Click, you know, click that little bell and get a notification next time we're running. You know, and share us with the world. Why not? Now, if we didn't get to your question, leave it in a comment or whatever, and Amanda or I will pick it up, and we will try and put that on the list for next time. I want to thank Paul and Keith from P&K Space Imaging, Bill New York Skywatcher as well, and of course the tireless folks that mod for me, including you, Amanda, who do a fantastic job. I couldn't really do this without any of you guys, that's for sure. You know, so without you guys, I'd probably be bored out of my mind all day, or building more observatories for no reason, and buying more cameras than anyone should be allowed to have. But look, thank you for watching, and keep looking up. I'll see you on the next SkyTour live stream, guys. See you later.